Hello, students. Good morning, everyone. I hope everyone is doing well.
Good morning, sir.
Good morning, Mishra. So, we welcome everyone to the Statistics and Exploratory Data Analyst Week 1 Day 2 live session. And today we have instructor Dr. Sandeep here. So, before starting the session, I request everyone to please set your chart setting default to meeting group chat and also stay on mute until and unless that you have a doubt. Okay. So, this will make like we can proceed the session very smoothly. So, hope everyone understood this. So, let's welcome our instructor, Dr. Sandeep. Hi, Sandeep. Good morning.
Good morning, Ravi. Good morning, everyone. So, guys, we are going to continue wherever we left yesterday. But before moving to the today's session, I will request everyone to send up, personal message. Don't send me personal message because there is some changes in Zoom, so I may miss your message. Please send me in the everyone message everyone, so that will be easier for me to see it. So before moving ahead, I would request everyone, if you have any doubt, any question, you can feel free to ask. Any question from yesterday?
Sir, morning, sir, Bhargavi.
Yeah.
How to calculate standard deviation, sir?
So we
Right,
will we will
it's out of data.
we will discuss today.
Okay, okay, okay. Thank you.
We are going to discuss dispersion part, standard deviation, interquartile range today.
Sir, if you could just give us a very small recap of yesterday. Like,
So yesterday we basically discussed about few things. So let me share my screen. So I have already opened. This is going to be a brief one because otherwise it will take time to finish. So we started with to understand what is sample, what is population. So population is nothing. It basically we are going to go do a study on the entire population based on our question. Okay. So based on the question, we are going to see do the task. Then we select a sample from the population because practically it is not possible to go for everyone or to select everyone to be part of our study because it can take so much time and it can consume a lot of money on. We try to collect samples from the population and we want our sample should represent population. Okay. Then we discussed about parameter, basically describing characteristic of a population is called parameter. Describing statistics, characteristic of a sample is called statistics. For example, we discussed about mean, median, mode. So if we are calculating mean, median, and mode for population, we will call them parameter. If we are calculating mean, median, mode for sample, then we will call them statistics. So why we have to know these? Because in real life, when we are discussing those things, or when you will be reading blogs, reading papers and all. So they will use these terms. They will not say I am calculating population mean. So they will just say parameter is this, statistics is this. So just seeing this term, we have to understand what is it related to population or is it related to sample. Okay, and then we discuss about we select sample and then whatever we get, we try to get inference about the population. For example, one example I can give you is from COVID-19. So you may have heard that during COVID-19, many times 70% of the population got infected. Have you heard this thing? Of like a specific city got infected during COVID. Wait, you might have heard these things, but they did not go to everyone. They just selected a random sample from the population and tested them, and based on that, they took their inference. Okay, so we discussed about random sampling is basically we give chance to everyone and just select people randomly from a population. For example, I will add a population of Hyderabad into my system, everyone, because we have their phone numbers, we have their Aadhaar ID, and then just randomly select 10,000 people from them. Using in Python code, I will just go for random selection. So this is basically called random sampling. We discuss stratified sampling. We discuss in very basic because sometimes we want to do a study on where males and females have to be the part of the study. If anyone is missing or if anyone's number is less, then it may not make sense. So then this is we create two strata like male, female, and then do the study. Okay. Then we select samples for males, select samples for females, random samples for males, random samples for. We discussed all of these. After that, we discussed about data types. We discussed data types are two types, qualitative and quantitative. Qualitative data is also known as categorical data. Quantitative data is also known as numerical. This is what we discussed. Categorical, qualitative, basically quality of data. It is further divided into nominal and ordinal level. Nominal level, we cannot do measurement is not possible. Basically, any mathematics doesn't make sense. And they cannot be ranked or ordered. Basically, we cannot say which one is greater, which one is lesser. Basically, I cannot say male is greater or female is greater if they are a part of my data set. So this is what nominal level data is. We cannot rank them. But in ordinal level data, measurement cannot be done. For example, class grade, I cannot say A minus B is how much. I have no idea. A can be 99, A can be 92 also. B can be 89, B can be 82 also. So we don't know what is the mathematics behind how much greater is it. But we know this thing that A is greater than B. So we can definitely rank them, but we cannot do any mathematics. So this is what ordinal level data is. So ordinal data can be ranked, but we cannot do any mathematics. So mostly you are not going to see any number over there. Okay. Then comes quantitative data. We discussed about numerical data. So they are in general two types, discrete and continuous. When we say discrete data, basically we are counting something. Okay, when we say counting, so there are two things. Okay, layman, they count money on. But the truth is we don't count money. We count notes, number of notes. Is it or not? Do we count money or do we count number of notes? Everyone. Okay, we count notes. But at the end we measure it. Whatever the value comes, that is the measurement. Then we have intermediate values possible. Sorry, intermediate values are not possible. We cannot have 1.5 car. We cannot have 1.5 kids. We cannot have 2.5 people in a mall. Okay, so this is what discrete data is. Basically, number of cars, number of people, number of kids in a family. All of these are discrete data. Number of COVID cases per day. Continuous is where we measure something like weight, height, and then they can also have intermediate values. We may round it off, but still we can have intermediate values like weight, height, age, price, salary. All of these are comes under continuous. Continuous data is further divided into two types: interval and ratio level. So interval is basically no true zero. When I say no true zero, basically means zero doesn't make sense. Like temperature. If I say 0 degree temperature, it doesn't mean there is no temperature. If I say calendar year, 0 year doesn't mean there is no year. Okay. But ratio level data, true zero is possible. Like if I say weight is 0 kilogram. So it means it is zero, true zero. And when we say true zero, negative values are also not possible. If I say height is 0 centimeter, it means it is true zero. So this is what we discussed. Then we discussed about numerical measure. We calculated mean, basically average. Then we saw how to calculate median. Basically, median is nothing. It is the middlemost value. We just arrange them and then we look for the middlemost value. And we try to understand when to differentiate what. Basically, when to use what. Mean is used when. Can you tell me when do we use mean? And when do we use median? If outliers are not there, then we use mean. If outliers are there, then we use median. And then we started measure of dispersion or measure of variability. Yesterday, we just started in a brief. Why is it important? Why is it important? Because mean is not sufficient to give complete picture. So that is why we also look for the variability. When we look for the variability, we discussed about one variability which is called maximum minus minimum. Okay, which is called range. Now we are going to understand what is variance. Okay, so what is variance? Anyone wants to guess it? So guys, another request is, if you are not asking any question, please keep yourself mute, because it distracts me also, and it may be distracting others also. Perfect answer, Shushma. So basically, when we say variance, it basically means how much your data is dispersed from mean. Okay, how much of your data is dispersed from mean? This is what variance is. Okay, basically means if this is your mean value, how much dispersion is present from the mean? So now, because we are saying we are looking for the dispersion based on mean, so what are you interpreting from this? If I say we are going for mean, so what are you interpreting from this?
Greater variability. I mean,
Uh, okay, so in the sense of when to use it. Okay, so variance is it like when you have outliers in your data, can we use variance? It quantifies the dispersion or spread, a set of, data points around their mean. Okay, this is what it looks like. We look for how much data is dispersed around the mean. So now my question, because you are saying yes, if we have outliers, we can use it. But the thing is, we are looking for mean. Now you tell me, can we use it? No. So another important thing is when we talk about variance, so that is the important thing. It means we cannot use variance if we have outliers. Okay. And we will see a few things about the shape also as we go ahead. Another very important thing is when we calculate variance, it measures the variability. Okay, it only measures the variability, but it doesn't look for the shape of the data. And we will see the shape of the data in the form of skewness and kurtosis. Once this part is done, then we will see those also. But variance doesn't account for the shape of the data. Okay, that is the one thing we have to remember. Variance only account for is only account only look for how much dispersion is present around the mean. This is what it looks like. Okay, when we calculate sample variance, so the basic formula to calculate sample variance is, remember, again, parameter statistics. For population, formula slightly differ in comparison to sample. So when we are calculating, so you can also make it note. So we calculate using this formula. So this is called sample variance. S square is equal to 1 divided n minus 1. Then summation. What is the meaning of this symbol? If I am using, yes, basically adding all values. Summation of x I minus x bar square. So I might have missed yesterday, but when we say sample mean, we use this symbol called x bar. When we say population mean, we say mu. So this is the basic difference. This is parameter, this is statistics. So this represents sample mean, this represents population mean. This is your sample variance. S square is called sample variance. So this is your basic formula to calculate sample variance. So I'm not going to do the calculation, but I will show you how easy it is. Okay. So let me open the, it is pop is a short form summary. Okay. When we say something, it is just a short form, nothing else. Okay. So pop or population, same thing. So just say this is my data point. So these are your, if I just go for the formula again, basically we can also write it like this, summation of xi minus x bar square divided by n minus 1. We can also write it like this. Basically, we are going to add all of these and then divide it. So what is xi in this? Okay, x bar is, what is x bar? In this formula, what is this x bar?
Sample mean.
Sample mean. So can we calculate it easily or not?
Yes.
We can definitely calculate it. Second comes what is xi. So someone has already mentioned, basically this is your observation. Okay. So if I go ahead with this formula, so the next line is xi minus sample mean. Can we do that easily or not? Can we do this part?
Yes.
Okay. We can simply do that. So if I go and just calculate average. Okay. And then if I go ahead, so this is your sample mean. This is your sample mean. 68.05. Now what I have to do is 65.2 minus 68.05. 62 minus 68.05. 75.1 minus 68.05. And then I will get some values here. Okay. So can you tell me what will be the first value? I will just go for one or two values because it will take too much time if I go for everything. What is 65 minus 2? 65.2 minus 68.05.
Minus 2.85.
minus 2.85. Same way I can go for all of these value like 62 minus 68.05. I did not use equal, so that's why I'm getting this. Okay. Then same way I can go for this, this, and this. So what will happen? So if I am going for 63 minus 68.05, so there are some values negative and some are positive. Is it or not? So what will happen if there are negative and positive values? What will happen?
The values which are in the negative, they are less than the, I mean,
So
mean value.
there is a huge possibility that these values will cancel out each other. Is it or not?
Yes.
Okay. And then what will be the left answer when we when it is left? So what will be the overall value? Close to zero, zero or close to zero. So will it is it going to say tell anything about the variability?
I mean, if the value is close to zero, then we can say the variability is less. I mean, dispersion is less.
Okay. So if you see when I am adding all of these values, this is zero. Is it or not?
Yes.
Okay. So, and this is summation. Why I'm adding this. So the formula to calculate is basically equal to sum, and then we give the cell number. So if you say, so if you don't know, so you can mention this thing like you can write it, this formula, how to add values. So this is basically sum, and then you give the cell number, whatever we want to add. Okay. So this way I am done. But what happens is when statisticians were actually, remember, everything is discovered. It is not like, we came with a book which is having everything. Everything is discovered. So statisticians found this is not making sense. So then what they did, they took the same thing here, and then what they did, they took the square of them. Okay. So I'm writing the square like this, power. So now what we are going to do is we are going to take the square of all of these. So equal to minus 2.85 multiplied by minus 2.85. So what will be the square?
8.12.
Hmm? 8.1225. Then same way we can do for all of these. Okay. So same way we can do for all of these, and we will get some values at the end. Okay, some values, basically the summation. And this is what we have seen. If I just show you this formula for variance, s square is equal to summation of xi minus x bar. Okay, and then divided by n minus 1. So here we will get these values. When we add all of these, we will get these values. Okay. So is it not we are getting this value? We is using this formula is equal to minus 6.05 multiplied by again minus 6.05. So this will become 36. So now I'm not going to use all of those. So just to make it simple, I'm saying 7.05 multiplied by 7.05. This is the value. Then equal to 3.05 multiplied by 3.05. I'm getting this value. Even if it is negative, we will get positive only. Then 9.95 multiplied by 9.95. I'm getting this value. Again 5.05 multiplied by 5.05. So this is the value. Now if I go and add them, sum of this. So this is 228.235. This is what you are seeing at the top of this formula. Then how many observations do I have? 6 observations. 1, 2, 3, 4, 5, 6. We have 6 observations. So what we have to do, n minus 1, which is 5, 2. So here it is 228 0.235 divided by 5. This is 45.647. And this way we are getting our variance value. But if you see these things, if you see these values and in compare to this variance, it looks very high variability. Is it or not? Okay. So this is the basic way to calculate variance. So the first thing we have to know is what is variance. Basically, if you see the whole formula contains something called mean, sample mean. It contains sample mean. So it means if you have outliers in your data set, variance is a good approach or bad approach. Variance is a good approach or bad approach? Bad. So this is very, very important to understand. So if we are using uh, variance, we have to be cautious with outliers in our data set. So if you see, are we getting same value? Okay. So this way we calculate variance. So and when we calculate population variance, there is only slight difference. When I'm calculating population variance, I am going to use symbol called sigma square. So your parameter is sigma square, and then summation of xi minus, which symbol I am going to use here? Is it x bar? Mu, perfect. Mu, but rather than n minus 1, we divide it by n. So this is the mathematical formula to calculate. So in sample, we are dividing it by n minus 1. In population, we are dividing it by n. Okay, so this is what variance is. So variance is basically is the measure to quantify the dispersion or spread of your data around the mean. How much dispersion is around the mean? This is what it looks like. Okay, so whenever your data has no outlier, you will use mean and variance. But the interesting thing about is, let me go back to the when we are calculating. So for example, when we are calculating, so okay, let me show the formula also. My mistake. If you see, the formula is simply var a. Okay, I am calling var a. So let me do it again. It will be easier. So here we have done most of the things. So let's go ahead and try to calculate variance here. The formula for variance is when we say var. Okay, so there are many options. First is var. Then you see variance of sample, variance of entire population, variance of entire population, variance of sample. So that's why I used var a, because I'm looking for sample. And then I am just going to give the values which we are going to look at. Okay, basically cell number. So F2 till F7, and then I am done. So this is 45.647. So my variance is 45.647. So I am sharing this formula with you. So you can also make a note over somewhere if you want. And I will also save it here. So this is what variance is. But if you look at the formula, one of the thing is when we are doing summation, xi minus x bar square. Okay. So if my unit is year, what will happen when I am converting into square? So my unit will become if when we are calculating this,
Yes.
this will become year square. So what happens is when we are using year square, so it is not going to make much sense. Okay, when we are using unit as a year square. For example, when I say someone is 5 years older than me, it makes sense. Someone is 20 more than 20 kg heavier than me. But if I say someone is 20 kg square, does it make sense? No. So what a statistician do is they came with another approach, which is called standard deviation. Okay, so they came with another approach That is called standard deviation. What is standard deviation? Okay, standard deviation is nothing, that is the same, that it also quantifies the dispersion as well as a set of data. Perfect. So what they did is, so when your S square is calculated, basically your variance is calculated. Okay, if you take the square root of this will become S. Is it or not? If you take the square root of S square, is it S or not? This is your standard. Okay, so S is nothing, this is your standard. The standard deviation is the same thing, but it has, now tell me, when I'm taking the square root, first your mean, okay, yes, both have same definition, both are doing the same thing. The only difference is in its variance is having a square of your values. Okay, okay. So, and mean is just for example here, let me write this. When we are using mean, so my unit is in year. Okay, when I'm using variance, my unit become year square. Is it or not? But when I'm using standard deviation, my unit again become year. So now is it making sense or not? So that is why you may hear about variance, but when we report our data, we always report standard deviation. Okay, we always report standard deviation. We don't report variance. Okay, technically both are the same thing, but variance is basically the square of standard deviation. Both are quantifying the dispersion or spread a set of data points around the mean. Okay, and the reason, one reason is because mean and standard deviation has same unit. So whenever you are reporting your data, okay, and there is no outlier, there is no outlier. Okay, we always report like this. We always say mean and standard deviation. We always report like this. Okay, we have to report both so people can understand, okay, how good your data is. Basically, they will understand, okay, what is the average of your data point and how much dispersion is present in your data. So is it clear what is variance, what is the standard deviation? Okay,
So, Sandeep,
yes.
what inferences can we make on our variance?
So when you get your result, so you are going to use standard deviation. Okay, not variance. You are going to use the standard deviation. So you will just report, okay, when I after check, when I check my data, or like when you're reporting it, so I found the mean value is this much, and this much dispersion is and then whatever the standard deviation is, this much dispersion is present in my data. Okay, this is the way we report, and then we try to interpret if this dispersion is too much or if dispersion is too less. So let's go to our data set and see how can we get it. So after variance, let's see how to get standard deviation. Okay, how to get standard deviation? It's simple, equal to, and then just write STD. So if you see X, this is standard deviation of sample. Then, sorry, it is coming for population. So second one is standard deviation for sample, and then F2 till F7, and then I will get the standard deviation is 6.75. So this is the formula to calculate standard deviation for sample. I'm sharing with you and I'm also writing it. So this way we predict it. So guys, please don't do this. Doesn't look good because your name also comes. Okay, so this is what standard deviation is. So this way. So what happens is now if I go back to this data set, this is 6.75, and when I see these values, so I don't feel there is too much dispersion based on these values. Okay, there is not too much dispersion based on these values. But if I just see mean and median, I feel this may standard deviation or variance may not be that good. Why there is huge difference between mean and median? That is also one way to figure out if you have outliers in your data set. Okay, so you when you are writing it, you will always write. If you feel it is good, you will write mean and standard deviation to present your report. So mean is 68.05 standard deviation. So you will report. So the average statistics scores in this class is 68.45, and the variability present in our data is 6.75. Okay, which is not much. Basically means we are seeing students are close to each other. Is it or not? What we are seeing, students are close to each other. Their marks are close. If I just change this 30, now see, there is a huge change. Is it or not? In standard deviation.
Sir, one more thing, like when you said 30 here, then which is the outlier here? 30 is the
That this is
outlier?
this is outlier. No doubt it is an outlier, because if you see the mean is 62, median is 65. Okay, which is clearly an outlier. But just to show you how are you going to see this standard deviation, I'm showing. If you see it is not there, is it not there is a huge difference in the variability? So what it tells me, yes, there are some students who are either scoring very high or very less. So just using this, now I can go and check, look for the students who are scoring less. So if I go for minimum, I will figure out, okay, there's a student who scored only 30 marks. So now what we will do, we can go to and contact this student and try to see how can we work on that. Okay, so the marks, so she can, so the person can improve his or her marks in later. Okay, because when you are working in a company, this is what you are going to do. The main aim is to figure out what are we doing very good, where are we doing bad. So if we are doing good something, so yes, we can definitely improve that part. But wherever we are doing bad, we can explore it and try to figure out, okay, this is going bad, and here we have to work on. Is it or not? You don't look for variance, Vivek. You only go for standard deviation. I showed you variance because the formula of standard deviation is coming from variance. Okay, so when you are doing it, you are only going to report mean and standard deviation if your data is perfectly fine. Is it clear now? You are not going to see variance, but because the formula of standard deviation is coming from variance only, so that is why I showed it.
Okay.
Otherwise, most of the people will not even discuss variance; they will just discuss about standard deviation.
Okay. Got it. Thank you, sir.
So this is what. Now the question is, what if we have outliers in our data? Then what are we going to do? So for that we have approach called interquartile range. So but before going for interquartile range, we have to understand what is percentile and what is quartile. Okay, so percentile is not that important, but it's just to go for so to have a simple look. So I'm going for this. So can you tell me what when, because I'm sure you have heard about this term called percentile. So what is percentile?
Percentile is maximum value of the data set. I mean, maximum value of the data set is considered as 100%. To that highest value, whatever the value that we are looking for, make that a reference, and out of that percentage, we make and give that percentage. That is percentile.
Okay, okay, perfect. So percentile is basically not your marks. Okay, just try to understand. Percent is your marks, but percentile is not your marks. Percentile is basically is a way to find, where a value stands in the rest of the data. Okay, this is what we do, where a value stands in the rest of the data. Okay. Just for example, if I say a student scored 70th percentile, okay, if you have taken an exam and your percentile is 70th, it basically means your score is better than 70% is people. For example, you have taken an exam and just for example, Python exam, and your score is 65 in 100. What is the percentage? 65%.
65.
But okay, but when we are calculating percentile, okay, while calculating percentile, I found your percentile is 70. So what it means, your score is better than 70% students. This is what it means. Okay, so this is what percentile is. Even your score is low, but your score is still better than 70% student. So what does it mean is, in generally, percentile divide our data into 100 equal parts. Okay, this is what happens. When we are calculating percentile, our data is divided into 100 equal parts. Basically, after arranging them from lower to higher, now it is totally divided into 100 equal parts. So your minimum value may be, like for example, Python score, your minimum value may be 20, maximum value may be 80. But now it is divided into 100 equal parts. And based on that, we try to see, okay, what is 100 percentile, basically who is the topper. The person who scored is like 100 percentile. Person who scored 20th, which is like 0 percentile. Okay, so this is what it means. So when you see percentile, 65 percentile, it means the person is above like 60%, 65% student. If you see someone is 99 percentile, basically means he is better than 99%. His score is better than 99%. So if I say 50th percentile, what does it mean?
My score is better than the 50 members who have taken the exam, and the value would be around 40. My score will be 40.
So no, it is, yes, it is not necessarily the value will be 40, because when you are saying 40, you are thinking about mean. Okay, it can be close to 40, it can be little bit away from the
Yeah,
40
true,
also.
true.
Okay,
Sorry. Yeah, correct.
so when I say 50th percentile, so basically means it is basically the first thing, my score is above than 50% students. Okay, this is the first thing. And second thing is 50th percentile, is it not the middle value when it is 50th percentile?
Then, yeah, yes.
This is your middlemost value. So if it is the middlemost value, then what is this?
So, median.
Perfect. Then this is a median value. 50th percentile is always your median value. Okay. Now comes to quartile. So what is quartile? So
20,
percentile, yes,
25%.
no. So first try to understand quartile is, percentile is basically when we are dividing our data into 100 parts. Quartile is we are dividing our data into 4 equal parts. This is what we are doing. So it means basically, if I say this is my data set, okay. So now it is divided into 4 equal parts. This is the first, this is second, this is third, and this is fourth. Okay. This is first part, this is second, this is third, this is fourth. So this is your minimum value. Is it or not? Is it minimum value if my data is arranged from lower to higher? Yes, it is a minimum value. If it is from, this is lower, this is higher. If my data is arranged, so this is your minimum value. This is my whole data point. Okay, this is my whole data set. It is starting from here, it is ending here. So this is my maximum value. Is it or not? Now comes to quartile. So this is your quartile 1. Okay, quartile 1 is nothing. Basically, this is your 25th percentile of your data. Okay, so it is not 25th percent, it is 25th percentile of your data. This is called quartile 2. So this is your 50th percentile of data. So what is your Q2 now?
Second percentile.
It is 50th percentile. What does it mean?
Median.
Median value. And then we have Q3, which is 75th percentile of our data. Okay, so this is Q1, Q2, Q3. So what does it mean is Q1 is about 25% of your data points. Is it or not? You basically Q1 is your score is better than 25% of the students, above 25% of the students. Q2 is again same. The score is better than 50% of the students. Q3 is better than 75% of the students. This is percent of the students. This is what it means. Is it or not? If we interpret it. If we interpret it, this is what it means or not? If someone's
Yes.
percentile is 25th, it means the person is scored better than 25% of the people. 50th person is scored better than 50% of the people. 75, this is what it, when I am saying it, so when I say Q1 is representing this part. Technically, this is the exact value, but it is better than these values. When I say Q2 is representing this line, but it is better than these values. When I say Q3, it is representing this line. Basically, this is an exact value, but it means it is better than these. This is what it means. So what interquartile range does is, interquartile range is nothing. It is, we say short in IQR, and IQR is equal to Q3 minus Q1. So if I am using only Q3 and basically means IQR is this box, is it or not? Is it or not? So it is again a range only. Range is max minus minimum, but interquartile range is Q3 minus Q1, basically containing only 50% of the observation. Is it or not? 25, 75. So we are just having 50% of the observations. So where are your outliers going to fall? Are they going to fall here, or are they going to fall this side and this side? Either towards max or towards minimum. Is it or not? So there is nothing called Q4. Either they will be towards this side or they will be towards this side. But my IQR is this value. My IQR is this value. So now you tell me, is IQR influenced by outlier? No. So in the case of outlier, what are we going to report? In the case of outlier, what are we? Yes, but this is what interquartile range is. So interquartile range is nothing. It is basically your 75th percentile minus 25th percentile. Q3 minus Q1. So is it clear what is IQR? Okay. So now let's see how to calculate IQR. Okay. So for that, first we have to know how to calculate percentile or quantile. Okay. So how to calculate?
So, sir,
Yes.
basically IQR interquartile range is something that falls within the quartile, right?
Within quartile, Q3 minus Q1.
So is it going to be always like that uniform like you showed, or it can be anywhere within the range, like from in your example it started from 25% and went percentile and went till 75 percentile.
Yes, it is always going to be this only.
Okay,
Okay.
so it's not
It
never
is
going to be 15 percentile to.
no. It is never going to be. It is always Q3 minus Q1. It is always this. So
Okay,
Q3 is always 75 percentile. Q1 is always 25%. So it is like middle 50% data
okay, always the middle one.
are always this. It is never going to change because this is the mathematical formula. IQR, the formula is Q3 minus Q1, and Q3 is always 75th, Q1 is always 25th.
So for
Okay,
this,
okay.
there is no
outliers, right?
Where?
For IQR, there is no outliers.
So if, remember, if there is outlier, there is no issue. If there is no outlier, there is no issue. Okay, because remember, your maximum value is towards this side, minimum value is towards this side, so it is not even accounting for them. Okay, so if you have outliers, IQR is not going to even look at. It is just looking for Q3 minus Q1. Okay, and outliers will be either towards maximum side or towards minimum side.
Sir, I have one doubt.
Yes,
So percentile, we have always seen using the percentile. So what is the use of IQR then if it is not considered the outliers?
the use of IQR is if your data has outlier. Okay, if your data has outlier, so how are you going to report it? You cannot report standard deviation. Can you report it?
No.
So then what are we going to report? We are going to report IQR.
Okay.
Because that is also variability. It is also telling us variability. Okay.
So can we also say that we are kind of cleaning the data by removing the outliers?
We can, because we are not removing the outliers. That is a different process.
I mean, not
Okay.
removing, but we are consciously excluding, right?
Yes, we are excluding, because if I report standard deviation, that will be wrong, because my mean will be influenced by standard deviation. Sorry, outlier. Is it or not? My mean will be influenced by outlier. Is it or not? We have discussed it yesterday.
Yes,
Yes,
it
sir.
does.
Yes.
It will be influenced. So if my mean is influenced, it means standard deviation is also influenced. So if standard deviation is also influenced, we cannot report it. So what we are going to report? We are going to report interquartile range. Okay, and then we will also explain how many outliers are there. Okay, we will look at the presence of outliers in our data set, and we will also report it. Okay, so because we are reporting interquartile range because there are outliers present. So that is side, that is completely different thing. You are talking about log transformation now. There are many kinds of transformation we can do, but right now we have to focus on what are these basic statistics are. Okay, so when you go for machine learning and all, there you have to do transformation, log transformation, box plots transformation. There are different kinds of transformation. You can perform those to remove outliers. Basically, not removing the outliers, it will basically handling the outliers. Okay, some
So,
scenarios.
so sir, it's like data pre-processing, right? We are pre-processing the data.
So that is called data pre-processing. Basically, you are performing some types of, data cleaning, data pre-processing over there. Okay. So in those scenarios, we can do that. But there are machine learning models where it is not required. They don't care about outliers also, like decision tree. If you have outliers, there is no issue with that. Okay. Is this point clear?
Yes.
So this is the way we can calculate percentile. So what we do, we write percentile, and then we get the cell number, and then we see what percentile do we want to look at. So if I go and calculate this, so I am getting this value. So 63.5 is the 25th percentile of my data. Okay, which is close to this. Okay. And if I go and calculate quartile, so quartile 1. So let's say write Q1 only. Q1. What is Q1? So I will write quartile, and then I will have to give the cell number F2 to F7, and then I have to tell which quartile, 1, 2, 3. So I am going for quartile 1. If I run this, expected number dot 3 are. This is the issue. So this is quartile 1 is 63.5. Even if you look for percentile 25, it is same. Same go, we can go for for quartile 2. Right? The same formula, quartile, then F2 colon F7, and then I have to write. So it should be equal to what? If I say quartile 2, it should be equal to what?
Median.
Median. So if you go and see, is it median? If I go for Q3 now, so equal to quartile F2 colon F7, and then I have to tell which quartile. I am going for third quartile. Now it is 72.65. So can we not calculate IQR now? IQR is equal to, sorry, IQR, this is equal to Q3 is 72.625 minus Q1 is 63.5. This is my IQR. Interquartile range is 9.125. Okay, so this way we can simply calculate IQR also. So is it clear what is IQR, how to do the calculation? So let me share the formula with you. You can remember. So only change you have to do is you have to write this one value. If it is first quartile, you have to say first. If it is second, you have to say second. If it is third, you have to say, okay. So this is what quartile is. Sorry, interquartile is. Is it clear or any doubt?
Sir, calculating the quartile and all good, but where? What is the purpose for to calculate the IQR?
So my question is, if I am calculating interquartile range, okay. So what is the part it is covering?
So 25 to 75.
So it is covering 25 to 75. So is it covering minimum value, maximum value?
No.
It is not covering. So if you have outliers in your minimum maximum, so is it affected by outliers? If you have outliers towards minimum side or maximum side.
Okay.
So the best thing is if you have outliers present in your data, we can simply use it to figure out. And another interesting thing is we can simply use interquartile range IQR to find outliers also. Okay. If you calculate IQR, okay, when we calculate our IQR, how to find outliers towards minimum side or maximum side? Okay, we can simply use this to find it towards minimum or towards max. Okay, we can use IQR to do that. How? If it is towards minimum, it's very simple. Q1 minus 1.5 multiplied by IQR. Okay, if a value is below this, whatever the value comes, if a value is below this, that value will be considered as an outlier. Okay, if a value is above this, the value will be considered an outlier. So this is the mathematical formula developed by statistician to get outliers in your data set. If a value is going to below this, it means that is an outlier. If a value is above this, then it is an outlier. Okay. So this way we can also find outliers in our data. Is this clear now?
Yes, sir.
Okay. So now that question was like, yes, yesterday you guys were thinking how to find outliers. We can simply use this to find outliers. And if I have to remove outliers, is it not like if a value is below this, trim that? If a value is above this, trim that. Outliers are gone. Is it or not?
Can you consider IQR is a sample data set?
So I calculated it. So IQR is nothing. It is Q3 minus Q1. So I calculated Q1, calculate Q3, and this is IQR.
So the percentile value we done it on 0.25. So do we
Yes.
always do on the same value? I mean,
No. It is just to show you these two are equal.
okay.
Okay, this is just to show you these two are equal, nothing else. So I can change it also. For example, I can go for okay, what is 0.9, which is 76.5. So that is this is the way Darshan statistician came up with. So there is no straightforward answer for this. But the thing is when they were doing it. So like just for example, if I use only one, what will happen? So it is like Q3 plus IQR. Okay. When if I use two, so they found if I am using one, so we are including some values which shouldn't be part of that. When they use two, they found two is basically we are adding some which we are missing some values which should be the part of maximum value. Sorry, in outliers. So this way they came with statistician come with this should be the exact value. So we should use this value should be the exact. Apart from that, we also have to use figures. Okay, it's not like this is hard and very hard and fast rule. Just for example, if your towards minimum just came 20.1, okay, when you did this, so it came 20.1, okay, and your value is 20, will you consider as an outlier? Now you have to see the graph. Based on the graph you have to judge it now, because it is very close. It is very close, 21, 20.1 and 20. If you just round it up, this will become 20. Okay, we have to judge it using figures. So after this, we are going to check the figures only. Okay, but first we will see figures and then I'm just giving an example, Supriya. For example, when you do this mathematics and you found your minimum after this, any value, if any value comes, this should be an outlier. And your value is 20. So should we consider as an outlier or not? This is where, a data analyst thinking come. We have to see this, we have to see figures. And using all of those, we have to decide. Is this point clear?
Yes, Sandeep. I mean, you mean to say, let's say I have calculated my towards minimum, towards maximum, and
Yes.
I have around 10 to 15% of my data set is having outliers with the towards minimum. So if I feel ki I should consider them, like rounding of like value like 20.01 or 20.02, there are like 10 to 15% of values around the value which I have segregating the outliers. So
Yes.
I can modify, I mean, rather than saying modify, I have a liberty to change my 1.5 value to either 1.45 or 1.4, so that I can
You don't have liberty.
okay.
Formula is very straightforward, but
Uh-huh.
you have liberty to judge are you going to consider it as an outlier or not. So
Oh,
you will create this, you will create figure also, and based on that you are going to judge.
okay.
Just for example, just a very basic example, greater than 200 is considered as higher cholesterol level. I'm sure like you many of you might have heard. Or greater than 125 is considered as diabetic. Fasting level, fasting sugar, if it is greater than 125 is considered as diabetic. Okay, so one person sugar level is 126, another person sugar level is 125. Now you tell me, I will say this is not diabetic, this will diabetic, this is diabetic. What should I say now? Just seeing these values.
126 is diabetic.
125 is not diabetic. This is as a layman we are going to say. But a doctor will definitely ask, okay, control everything, come after a month, and then we will check it again. Okay, because this can be due to error also. This can be due to error also. So they will not consider this diabetic. They will definitely go for another test after a week or after 10 days or after a month. Okay, so this is the way we have to think because they are expert, so they know this. Those who are not expert, like when I was studying statistics, we have to think, we have to develop this thinking, when to get rid of data, when to use it. Okay, how are we going to use it? So we never go and try to do something straightforward, and I will show you why in a minute. We cannot just rely on mathematical values blindly, and that is where figures are becomes very handy. Okay, so figures become very handy. So there is something called Anscombe quartet. So let's take a break here. We will go with that and try to see some figures.
Sure, Sandeep. Okay, guys, let's go for a short 10 minutes break. Yeah. Okay, students, welcome back from the short break. So, Sandeep, how are you?
Sure, Ravi. So guys, any question, any doubt before moving to the data visualization part for statistics? But remember, one thing is the main aim is for us in this session is to understand what type of data is used for what type of graph. But as you go ahead, when you will learn either Power BI or Python, you will go beyond. Like whatever I'm going to show is at a basic level, but the main aim is to understand what type of data is used for what type of graph and how to interpret it. Okay, there you will learn all of these with high level of graphs. Okay, how to create far better graphs, how to create more high level of graphs. So don't worry about that. But the main focus is which type of data is used for which type of graph and how to interpret. Okay, so this is what we are going to discuss now. So let me share my screen and start. I'm going to start with this Anscombe quartet only. So if you see, this is from Matplotlib, and this is the plot he created. Okay, so this is the plot he generated using some data set. So if you see this plot only, so if I just show you this plot, so can you tell me all of these graphs are same? All of these graphs are same. If you I just show you this graph, no. But if you just go and check these mean values, are they same?
Yes, sir.
If you just see this standard deviation, are they same?
Yes.
Yes,
And
sir.
this is called correlation. Are they same?
Yes.
Okay.
Yes.
So what happens is if we do not create these graphs, just using these values, what are we interpreting? These are same data points, or all of these have same mean, same standard deviation, and correlation is same. But as soon as I see the graph, it clearly tells me here we have an outlier. All of these data points are falling here, but we have an outlier here. All of these data points are on this line, but we have one value which is far beyond this. This data points shows me a linear relationship because I am able to go for a straight line, but here I am seeing a non-linear relationship. So all of these we are interpreting using this. So that is why it is, whatever we have discussed mean, median, mode, that is very, very important. We have to calculate it, but we cannot judge everything just using those. We must have to create figures wherever we can do, and then we have to judge using your descriptive statistics as well as data visualization technique. Is this point clear why data visualization is very, very important? So this is called Anscombe quartet because this was discovered by, basically this was explained by scientists called Anscombe. So that is why it is called Anscombe quartet. So is this point clear to everyone why data visualization is very important? Okay, perfect. So now let's go and try to understand different types of graphs. Okay, data visualization. So the first graph which we are going to discuss is a very common graph known as bar graph. So I have some graphs for you to show, and then I will also show you how to create this into. So this is called bar graph. So what is bar graph? So let me write here. So it is like bar, pillar. So that is because of pillars, so they are known as bar. So what bar graph basically tells, it in general, based on a statistical point of view, it tells the count in each group or category. This is what it tells. It tells the count in each group or category. So if you just see this group or category, so you judge what type of data are we going to use?
Nominal or ordinal data.
Perfect. So for categorical data or qualitative, okay, so it is always used for qualitative data. It is always used for qualitative data, but sometimes also for discrete level. If you remember when you were seeing those COVID graph, if you remember the COVID graph, like number of day one, this many number of cases, day two, this many number of cases. So they were not showing any other graph. They were showing you bar chart only, because each day we were having some count. So even the graph I am showing you right now is basically it is number of cylinders in car. So if I say number of cylinders in car, this is 4 cylinder, this is 6 cylinder, and this is 8 cylinder. So is it not a discrete data? Is it or not?
Yes, it is.
Yes, sir.
It is discrete, but I am still using to create graph because I want to see how many cars have 4 cylinders. Basically, I want to do a count here. Is it or not? How many cars have 6 cylinders? How many cars have 8 cylinders? So when we are creating graph, we have to see, we have to think, what is my question? My question is, I want to, in this scenario is, I want to see the number of cylinders in the car. This is what I want to see. Let me write here. Okay. So basically, count of cars based on number of cylinders. Because as I mentioned, it is count. So I am going to create a graph, bar graph. So bar graph basically tells me, okay, we create to see the count in each group. Basically what I did, number of 4 cylinder is one group, number of 6 cylinder is one group, number of 8 cylinder is one group. Now we are seeing the count. So this is what we do when we are dealing with either qualitative data or categorical data, or many a times during discrete data also. Now, is this clear when to use bar graph? Is this point clear? When to use bar graph? Which data points we have to use? First thing is, whenever we are interested to see the count, we are going to use bar graph. Okay, and count is mostly during categorical data or many a time for discrete data. Now the question is, how are we going? What are we going to interpret from it? So if I ask you, can you tell me which car has the maximum number of cylinders? Which car has the maximum number of cylinders?
Car 3.
Car 3. Everyone agree?
Blue color.
Basically, cylinder having 8 cars. Okay, sorry, cars having 8 cylinders. 8, 6, 4. So this is our interpretation. Yes, Murli, the example I am giving is discrete data. When I'm saying this, this is discrete data. For this, even for discrete data, we can use bar graph. Okay. So if you see, based on this plot, we have, what are we going to explain? So the plot suggests there are 14 cars, or we can say in this group, we have maximum number of cars belong to 8 cylinders, and the minimum number of cars belong to 6 cylinders. Okay, so this is what this is also called storytelling. For example, if you are presenting your data, or if you are explaining your data, you have to see what is the best way. You cannot just, if I just write maximum cylinder 8, minimum cylinder 6. So this is your count. So this is your x-axis, which is basically group, your 4-cylinder car, 6-cylinder car, 8-cylinder cars. Y-axis is your count. This is your count. So this is 11 cars, 7 cars, 14 cars. Is it clear now? So this is basically count. In each group, what is the count?
In y-axis, we labeled the total count of cylinders like that, not the total cars.
Yeah, okay. So this should be the total count, the total number of cars. It should have been total number of cars. Okay. This should be total number of cars, not total number of cylinders. Okay. Just removing this. Basically, y-axis represents the count of each group. This is what represents count of each group. X represents groups, Y represents count of each group. Is this clear now? Okay, so is it clear how to interpret a bar graph? Everyone. Okay, perfect. So now let's see how to create a bar graph in Excel. So I'm creating a sheet 2 here. In this sheet, I am just going to have, some month. Technically, when you will have data, it is going to cover all of this. And then I am having product. Some products was developed during these months. So for example, uh, there are 20 something product A was developed in January, then 30 was developed in February, then 25 was developed in March. Okay. Now if I go and create this graph, so I have to select both column. Then there are two ways to create a graph. Either you can go to these three dots which says more and then click on chart, insert chart. That is the one way. If you are not able to find this, you can go into insert and then there is another option called chart. You can choose whatever the way is feasible for you. If I click on this, it is automatically creating a graph for us. So if you see, is it a bar graph or not?
Yes.
Okay. So it is creating a bar graph. So automatically, this is the advantage of AI. So Google spreadsheet is automatically creating a graph for you. Excel may not do this. Okay, so that is the advantage. And then if you want, there are many things which you can learn as you go ahead. You can choose the chart style. You can choose the background color. So if I go and say I want everything in yellow, I can do that. Okay. Similarly, I can choose the chart border color. Let's create a back border. I can do all of those. You want a 3D? Let's create a 3D plot. We can do everything using this. If I want, I can change the title. So the product A versus month. If I want to change it, I can do that. I can change the font size also. If you see font size is changing. I can change the color of the font also. So we can do all of this. We can go and customize everything. We can add error bars if required. We can go and add legend if we want. We can do everything using this customize. Okay, so that is not necessary to learn because when you will be learning Python or Power BI, you will learn all of those into much better way. But this is what we can do. If we have to change the chart type, we can also click on this and we can column chart and then we can go and do the changes. Okay, so we can go and do the change. So this way we can create a chart using bar chart using spreadsheet in a simpler way. So is it clear? So you can also try using the same data. Let me share it with you. So this is month and then product, and you can try to create a graph. So again, there are two ways. One is you can go. So in Excel, there is something called descriptive statistics, which you can use and do that task. You can calculate all of those together. Okay, so let's create this graph and let me know once you are done. So you can go into insert, click on chart, or you can go and check these three dots and then do the task.
Sir, which Excel do we need to use, or we need to create the spreadsheet on our own?
Yes, just create this data set.
Okay.
Or I'm also going to share a data set with you guys, so which you can use also if you want. So this is called diabetes data set. Okay, so I have shared this data set. Please download it, and then you can import it into your Google spreadsheet also. For example, how to import it? Go into File, click on Import, and then once it is comes, click on Upload. Once upload is come, click on browse, and then you can choose the file. This file, open, and it will be opened into your system. Okay, I already have this file, so I'm not going to open it, but I am going to put it. Okay, so you can use that file. And for example, you have to see which data point is good to create bar plot. So what I found is pregnancies may be a good option to create me a bar plot. So I'm selecting this column. I will go to this chart, click on the chart, and it is giving me this line chart, which is wrong. So I will go and try to figure out where is bar column chart. Now if I create, it is still not giving me the correct value. Why? Because there are so many. So that is why it is a discrete value, but still it is not giving me the correct, even if I go for the column chart. So that is why I said many a times we can use it, but we have to be cautious. Here I cannot use pregnancies as a bar chart because I cannot interpret anything from this. Okay, what I will do in this, then I will go for this outcome column. So if you have to see, this is diabetes data set. Outcome is 1 is person is diabetic, 0 is person is not diabetic. So I will go for this one and then try to. Okay, so what happens is until unless if it is a number, so that is why it is not taking it. So when we are creating chart, specifically in Excel or spreadsheet, we have to convert this into categories. Like 1 should be diabetic, 0 should be not diabetic. Then only it will cover everything.
Sir, can you repeat once? Actually, I was importing the file. The call
So
was.
importing the file is, I will not suggest to do in this one because that can be an issue because all of these are numbers only. So that is why it is not taking. So if you have want to get this data set, click on go into file, go into import. Okay, click on import. Then it will ask you, you will see this upload option. Click on upload. Then you will see browse option. Click on browse and then try to open this file. You can click on the file and it will be. Okay, just open it. You can open it. Otherwise, you can just simply create a smaller data set, which I just showed you earlier, and you can use that.
Sir, in the diabetic data set which you just shared,
Yes.
through this bar chart, we doesn't make any sense, na? Through this bar chart, what we are coming to know,
No,
we
it
can't
is not
visualize.
it is not going to make any sense. The first thing is we have to convert it like this. Are you seeing this?
Yeah, yeah. This
Okay.
one, which is smaller sample, which makes
No, no,
sense, we
it
can
is
understood.
not. No, for example, what happens is here we have to find first thing is status. Okay, and then count. What we have to do? Diabetic and non-diabetic. Then we have to get the count, and then only we will be able to. Okay,
Understood, sir.
so
Understood.
this much we have to do before doing. No, it is not stuck. So if you want to create, so for this data, it completely depends. Okay, so number of pregnancies or outcome, we can do that one thing. For example, like if you see, there is a function, mathematical, spreadsheet. There is a function called count function. Okay, the count function we have seen yesterday to just to know how many values we have. Is it or not? Count a colon a. This is what we have seen yesterday. So this tells me I have 768 data points. If I go down, I can see that I have 768 data points. Okay, so this is what it is telling me. So I have 768 observation. I want to know how many 1 and how many 0 are there. For that, we have a function called count if. So if I go and say count if, then I have to give the observation, which is I column, I2 to I769. Then I have to tell what do I want. So I want to count how many diabetic are there, which is 1. And if I go for here, now if you see, this tells me it is 268. I just have to do the minor changes in this formula. Then I will say 0, and then it will show me 50, 500. So there are 500 non-diabetic, 268 diabetic. So I can go and do the change here. So diabetic are 268, non-diabetic are 500. Now I can simply go and create a bar chart on. When we are creating bar chart, the data should look like this to create it. Is this clear now? Is it clear? So you have to do these changes. So just try to remember this function. This is going to be very, very handy if you are using Excel or a spreadsheet. So you have to call this function called count if. Then you have to select your column which you are going to look at from beginning till end, and then you have to give your category number. So for 1 it is diabetic, 0 it is non-diabetic. So this is what I
So
did
what?
here.
So what does this mean? 1769. It's a formula.
No, it is not I2. This is your I2 column. This is your I. This is your I2. You are starting from I2 and then you are going till end, which is I769. If I go here, this if you see the last column, so that is last observation,
Understood, sir.
7769. So this is the range. So whenever we write this formula, we have to use these ranges. Is it clear now?
Yes, sir.
Okay, so this way I got the count. Now I created a new spreadsheet where I am having basically I am having the values, these values, and then I am able to create. So to create a bar graph, we need something like this. Otherwise, it is impossible to create. So let me go and create it. This file. This will be if I go insert chart. Okay, so this way we can do this. Is it clear to everyone? Okay, perfect. Now we are going to see another chart. So I want to show you before some and something. So I I769 and go for. So if you see, I just showed you, I'm just using this formula. So many a times, if I ask you, what do you see? What do you feel if you have diabetic and non-diabetic people in your population. Okay, you have diabetic and non-diabetic people in your population, because remember you are also seeing some bits of EDA also. It's good. So are you going to calculate their glucose level together or separately? Zero for non-diabetes, one is for diabetes. So are you going to calculate their sugar level together or separately?
Separately.
So technically what happens in EDA, we will do everything together. Okay, we will, what I'm going to do is, let's do it for together. Okay, so but first we will see, because as an EDA we have to do everything. I am calculating average, and then B2 to B769. So these are my number of observation. So my average is 120. Okay, when they are together. Okay, but now if you see this formula I'm sharing with you. So this is a very interesting formula. So I will suggest to remember. Or so this formula is basically average if, not average. It is average if. What it means is, in this column for non-diabetic, calculate the average of glucose. This is what it means. So where we have categories here. So I am using first, I am using I2 till I769. This is what I am using here first, because this comes from, this is my category. Basically here I have sugar, people diabetic or non-diabetic. So this is what first thing is. Then in this column, what does zero means? Zero means non-diabetic. Okay. And then I am saying, what do I want to look at? I want to look for the glucose. So what is the average of, so this is what this formula is calculating. Average glucose level in non-diabetic. This is what it is calculating. Average glucose level in non-diabetic. Okay. Now if I go and do some minor changes in this formula, so rather than 0, I am using 1. Now if you see, what happens is, if I just say average value of everything together, and if I see the same value when we are just diabetic, same value when they are non-diabetic, is it not like if I combine them and calculate everything together, it is going to, we are going for misinterpretation? Are we going it for or not? The average value when diabetic and non-diabetic are together, then it is 120.89. But for diabetic, it is 141, and for non-diabetic, it is 109 or 110. So this is what we have to see. If we have categories, and we know basically from the field, we know that diabetic and non-diabetic cannot have similar level of sugar, or can they have? If a group is diabetic, okay. So this is the way we have to do. We cannot just go and do one. Okay, let's calculate average for this, and then we are done. This is very wrong approach. We must have to explore our data more, and then we have to present it. Okay, together it is 120, but diabetics have much higher value in comparison to non-diabetics. This means diabetes have higher sugar level in comparison to non-diabetics. Okay, this means diabetics have higher sugar level in comparison to non-diabetics. This is your count. Count is this 268, 500. Only 268 diabetic people are there, 500 non-diabetic people there. But this is the mean sugar level. Mean sugar level of diabetic, mean sugar level of non-diabetic. Okay. So this is what I wanted to show. Whenever you have categories, it is always good to go and explore as much as possible to get the better correct result. Okay. So this way we can do that. Another graph we are going to see is called, group bar chart. So that is not a big thing. It's like very same. It is again a bar chart, but I'm showing you group bar chart. So this is like 52, 21. So group bar chart is basically what we are doing. We are comparing product A versus product B based on the data. So if I go ahead and try to create a group bar chart, if I click, it should be automatically. Now if you see, this is group bar chart. So now I am having product A in blue color, product B in red color. And then based on that, we can see what were the production. So if you see, based on this, can I not say that in January and March, production of product B was more, but in February, production of product A was more. Okay. Can we say this? So this is called group bar chart. Let me see if I can copy this. Okay. So this is what group bar chart is. So this is another chart called group bar chart. Okay. Now let's go to the third one. Third one is called pie chart. Have you heard about this?
Yes, sir.
So let me give an example.
Look like circular.
Yes, it is like pie, like pizza. So this is the example of group bar chart. So here we have again number of cylinders and then their count. We are trying to compare based on automatic or manual. So this is called group bar chart. Let's see something called pie chart. So pie chart, like just like group this bar chart we are using count. In pie chart we go for percentage. We are trying to see the percentage of data in your categories. Okay, so what does it mean? Which type of data are we going to use for pie chart?
Categorical data, numerical data.
Categorical data. Okay, so what we are going to check it in pie chart is we are trying to see the percentage of observations in your data. For example, what is the percentage of diabetic people and what is the percentage of non-diabetic? Okay, and if you are looking for percentage, what should be the total percentage?
100.
100.
100%.
So if I just show you this graph, so what it tells me when you are creating pie chart, so percentage of categorical data. So this is what we do. We use pie chart to see the percentage of categorical data. And how are we going to interpret? When we will interpret, we will say in this group, there are group 3 has 47 percentage, has the maximum number of people like 47 percentage, and group 5 has basically cylinder 3, 4, 5. So cylinder 3 has are present in 47% in this data set, and cylinder 5 is the least, which is 16% in the data set. Okay, so this way we can present it. So let's see how can we create it. So to create this, again we need the similar data set. Okay, we don't want to do any change in this. For example, uh, even to create pie chart, we need something like this. Okay, if I go to insert, click on chart, it by default it is creating pie chart. And if you see, it is also giving me percentage 34.9% diabetic, 65.1% non-diabetic. So this way we can create pie chart. If it is not creating automatically, go click on chart type, and then if you scroll down, you will find pie chart. If you click on this, it will. So this way we can create pie chart also. But the most important thing again is we need our data set should look something like this. Is it clear now? What is pie chart? Which type of data is it used? Again, just see it, try to understand it more. There are hundreds of examples online how to create pie chart and all using spreadsheet. But the main thing is when to create it and how to interpret it. Okay. Now we are difference is bar chart gives you count, pie chart gives you percentage. You can also get like in Python or if you go Power BI, it will give pie chart will give you both. It completely depends on which pie chart are you going to prefer to present.
Sir,
You can
once
use
can you
both of
show
them.
the again pie chart, sir?
So it's like your data should look like this. You should be having your categories. Click on this, go into insert chart. It should create it automatically. If it is not, it may create bar chart also. Go into chart type, is setup, chart type, click on this, and then if you scroll down, you will find pie. You can click on pie and it will give you the result. But there are many other examples like donut chart, like donut. So the same thing, but now it is a donut shape. Okay. If you want, you can definitely do the changes here. And this is your 3D. So you can create a 3D one also. And you want, you can customize it. Chart style, you can do the changes here. Pie chart, you can go and do the changes. Whatever you want, you can do, customize it here. It's not very tough. Even if you just explore it, play with, you will learn. Some months you will learn during there. Okay.
Okay, sir. Thank you.
Yeah. When you will learn Python, you will learn those things over there, or you will learn during Power BI. Okay. Because to know, you have to know Python first to do all of this. So this is what pie chart is. Next comes, we are going to discuss another very important chart, which is called histogram, and this is what we are going to use a lot. Okay, histogram. So histogram is looks something like this, and this chart helps us to understand two distribution. One is called skewness, another is called kurtosis. We will discuss those also with this histogram. So histogram is basically what it tells us. It is always going to be used for continuous data. Okay, either a ratio interval doesn't matter. We use histogram for continuous data. It looks very similar to bar chart. Okay, and it also tells you this nearly same thing. Frequency is nothing, it is count only. In histogram, we just say we are going for frequency. It is count. What is the count here? What is the count here? What is the count here? But what this count mean is slightly different. Okay, so when we discussed about bar chart, what was the meaning of count? Count was basically in each group, what number of values, is it or not? The number of values in each group. This was count in bar chart. But here it differs. Just for example, when we get a data set, remember in continuous data, if I am dealing with age, there may be 70, 80 values. Is it or not? 70, 80 different values in each column. There can be. So what happens is when we are creating it, it creates frequency. It is based on frequency distribution. So what does it mean is when when the chart is created automatically, what it does is, just for example, it's from 0 to 5 years and then count of this. Just for example, there are 7 kids who are 0 to 5 years. Okay. Then it will go for 6 to 10 years. Then there are 15. Then it will go for 11 to 15 years. And then if I say there are 21, then it will go for 16 till 20 years. Then we have around 28 people. This way, what is happening? We are creating frequency distribution. Basically means rather than going for each age separately, we are creating a group of them. 0 to 5 years, we have 7 people. 6 to 10 years, we have 15 people. 11 to 15 years, we have 21 people. So this is the way we create it. If you see this graph, so this is your value. So this is feels like 12 to 15 years. So this much count. 15 to 17 years, this much count. 17 to 20 years, this much count. And 20 to 22 years, this much count. So this is what happens. This is count from 20 to 22 years. This is the count 18 to 20 years. This is the count 17 to 20, sorry, 18 years. So this is what happens. Based on these frequency, we are seeing the count in a histogram. So this is called bin. In histogram, we call them bin. So bin number 1, bin number 2, bin number 3. So is it clear what exactly we are doing in histogram? Then we will see how to interpret it. Is this point clear? What is happening here? What is your x-axis? What is your y-axis? So rather than each age group at once, we are creating the group and then we are looking for the count. In bar chart, when we use bar chart, yes, x-axis is basically the frequency of age. Basically, sorry, frequency is here, the group. Basically, we created the bin. Okay, we generally say we have created the bin of 0 to 5, 6 to 10. So even in basic English, we say, okay, just create a bin. Okay, so this is what happens. So this is the one thing. So whenever bar, we say bin. So this is 1 bin, this is 2 bin, this is 3 bin, this is 4, because we also define how many bins we want how do we want to create it. It is by default, these things will create something, but we have to change the number of bins to see which one is making most. We can say Murli, we can indirectly say that, but technically when we are dealing with the real life people, never say bar. It is good to say bin. Okay. So this is what
Sir, bin is also
yes.
range.
Yes.
Bin is also range.
So this is range. This is your minimum value. This is your maximum value.
Okay, okay.
Okay, but you have all values. What you are seeing here is this is your count. Okay, so what basically what is your x-axis? What is your y-axis? I think it is clear. But why we need this graph? Okay, what happens in real life is when we are creating something. So we expect most of the data should be normal. Most of the real life data should be normal. This is what we expect. For example, weight. So are we going to expect that most of the people are going to be 200 kg or most of the people will be 40 kg? Are we going to expect this, or are we going to expect this like most of the people will range between 60 to 90 kg? What are we going to expect? Then the lower people will be towards left side, higher people will be towards right side. So this is what we expect. We expect our data should be normal. When we say normal, so this is the most commonly expected distribution. This is the most commonly expected distribution. So this is called normal distribution. Okay. So we use histogram to see if my data is following normal distribution or not. This is what we use it. Yes, we can say counter frequency is same. Yes, I have already mentioned this. This is for continuous data. Histogram is used for continuous data. So what we are seeing in this graph is we are seeing my data is following normal distribution. So what does normal distribution in general means is when I create a straight line at mean. So just imagine this is my mean. So my 50% of the data will fall here, 50% of the data will fall this side, 50% this side, 50% this side, and they will be nearly identical like mirror image. They will be nearly identical like mirror image. This is what we expect in a normal distribution. So we create histogram to see how my data is distributed. Is it normally distributed or not? This is what we try to see using histogram. So can you tell me, is it following normal distribution? There are many types of distribution because this is the most common one we are expecting. So that is why it is called normal distribution, because this is the most common one. Okay, and then we will see what is skewness in a minute. Okay, in a minute. So this is what we see. What it tells me, yes, when we have created this graph, yes, my data follows normal distribution, and most of the data points are lying between somewhere here, between 25 and 35. Is it or not? Most of my data points fall between these two values. That is why we are having too much bigger bins. That is why we are having bigger bins here. So this is what we interpret. If we have outliers, then this graph will change. Then this graph may look like this. If it has outliers towards right side, your graph may look like something like this. So if I create a plot like this here again, so then it will be slightly different. Is it not? It is stretching towards right side more. Here, there is no stretch, similar stretch towards both sides. But here, if you see, is it not stretching towards right side? Because we have some values towards this side. Is it or not? Everyone?
Yes.
So this is called skewed data. Basically means your data is skewed, and because it is stretched toward right side, so it is called right skewed data. So here what we are trying to see, we are trying to see this, symmetry of the data. Symmetry. What is the symmetry of my data? Okay, because it is stretched toward right side, we say right skewed. This is called normal distribution or symmetric distribution. Okay, symmetric or normal distribution. This is what we call them. This is called right skewed data. But if I create a histogram, which is something like this, no, it is not based on mean. There is nothing called mean in this concept. Okay, your mean value will fall somewhere between only, but there is nothing called mean here. Now you tell me if my data, if my graph looks something like this, is it symmetric or skewed?
Skewed.
Is skewed. Is it right or left skewed?
Left skewed.
It is left skewed. So now you try to guess when your data is symmetric or normally distributed. My mean and median will be same or not? Nearly same or not? If it is symmetric,
Yes,
Nearly.
sir.
everyone.
Yes,
Yes,
sir.
sir.
Okay, this is what we see when we calculate mean median. If they are close to each other, it means my data is symmetric. What will happen if my data is right skewed? What will be greater? Mean will be greater or median will be greater?
Mean will be there.
Mean will be greater. Perfect. Why? Because of outliers present this side, my mean will stretch towards right side. So my mean will be greater in right skewed data. So if you calculate mean and median and your mean is quite high, so what are you going to judge? My data is
Skew.
right skewed. Skewed
Right.
definitely, but right skewed. When it is left skewed, what will be greater, mean or median?
Medium.
Median will be greater. Why? Because mean will be stretched toward left side, so your median will be greater. So it means your data is skewed towards left. So this is the, just using these histogram we can judge it. So not only using those mean median, we can also create histogram to judge all of these. So let me write all of those whatever I have just explained, skewness thing. So normal. So skewness basically, if if mean and median are equal, basically nearly equal, and graph is symmetric, then it is symmetric distribution or normal distribution. Okay. In generally, this is what we say, symmetric or normal, but I will also try to differentiate as we go ahead. But if it is left skewed, basically means your data will be, tail will stretch towards left. Basically means median is greater than mean. When it is right skewed, tail will be stretched towards right. Then your mean is greater than mean. Okay, so this is what we are going to see if based on histogram and basic descriptive statistics which we have. So let me share a graph with you, which I have already created earlier for my thing. So I'm going to share this skewness graph. So you can keep it with you. If you see, this is the graph I had created earlier. So this is your right skew, this is your symmetric distribution, and this is your left skew data. If it is symmetric, we expect mean, median, and mode should be equal. If it is right skewed, our mean is going to be higher. If it is left skewed, our mean is going to be the lower. So is it clear what is skewness? What does skewness means? What is left skewed or positive? Remember, left, right is skewed or positive is skewed, left is skewed or negative is skewed, and symmetric distribution. Okay, these are the three things. So let's take a break and then we will go ahead and see a little bit more thing about skewness and other graphs.
Guys, I hope everyone are back from the break. Can you please confirm me over a chat? Thank you for the confirmation. Sandeep, it's over to you.
Sure. So guys, any question, any doubt about histogram, how to interpret it, what is skewness? If you have any question, any doubt,
Sir,
yes.
sir, how do we know the formulas about the IQR? That means we did that formulas right, sir, F1, F7, like that. How do
So
we know
for
that?
so
You shown the data, that diabetics data in the sheet, right? In that
yes.
data, how we do know the formulas? How do we know the formulas? Q1, Q3, like IQR, in IQR.
So for IQR, you have to calculate quartile first. Okay. You have to calculate these quartile. If you see when I created this, so I am calculating this quartile first. Quartile 1, quartile 3, and this is just Q3 minus Q1. Okay. Are you
Okay,
getting this?
sir.
He is asking specifically that range, like A12 to
Yeah, yes, sir.
A20, like that.
Okay,
That
see
range he is
this
asking.
range.
Range.
Okay, so you
How do
want
we know that formulas that?
so there is like remember I discussed one formula yesterday that is called count. So that is called count, and then you can choose any column and then A and then E. Okay. So this formula will tell you how many values do you have. So if you go, it tells me for some reason it is telling me correctly. Yesterday it was showing issues. So if you see, it is telling me this is 768. Okay. So I have 768 values in this column, excluding excluding column. Yesterday it was including column name, but today it is excluding them. So that is a funny thing. So if you see 769, and if when I use this formula, it told me 768, which is excluding this column. Okay, excluding this column. So it means if I'm starting from I2, it will go till, because this is whatever the value is by observation is starting from 2. So this will go till 769. So this is the way I. The formula is called count AA. If you remember, I have shared this also yesterday. If I go back from yesterday's class. This how many rows you have. So this way I can know how many rows I have, and this is the way I can select the value.
Yeah,
Is it clear now?
understood, sir. Yeah, understood. Thank you, sir.
Because this is small data set, you can scroll and get it. But in the real life, if you have 1 lakh rows, then how are you going to get it? You have to use this one.
Yesterday it was like not the numerical value, so it counted the first column field also.
Yes, exactly. This is interesting because the same formula was counting first value also. So let me see if it is related to cell also. It is not counting today. Okay, so maybe due to some AI issue. So it was counting yesterday when I was doing it. It was counting column name also, but today it is not counting, which is a weird thing. But this is what we are seeing today. Okay, so this way we can get. So we just have to be very sure. Like once you get it, we know where to go. We can simply scroll and we can go till that point. So this way we can know.
Sandeep, correct me if I am wrong. So the count, whenever we are doing that, counts only the value cells that are numeric, right? When we use this count, I mean yesterday that
This is what, yes, count is always for numeric values. Count is never for categorical data. For example, if I go Technically, it looks for how many values, like when we do the count formula, basically it looks for if we have values or not. If we have values somewhere, it will look for that. If not, then it will not go for that. Okay, it will come as empty. For example, if there is no value, it will not count. Okay, is this clear? Is this point clear?
Yes, Sandeep. Can you count on column A and column H as well?
It is 0 because this is character variable. Okay, is this clear? And if I go for column H, it is 6. 1, 2, 3, 4, 5, 6. But for some reason, if you remember yesterday, it was also counting this. Technically, it should have not, but it did.
Sir,
It. Yes.
yesterday we have mentioned count A slash 8 semicolon A, and today
So
you
we
are wrote only count.
Sir,
okay. Yes, I use count A. That is, I use not count. I use count A. The number of values in a data set. Okay, so then it is going for A. Yes, you got me correctly. So if I am using count A, it is going to count everything. There are many like count A, count if, count blank. There are many formulas. So yesterday I used count A, not count. So if I use count, then it is going to, I use count A. The reason was because count, if I'm using count, okay, just for example, if I remove this value and if I go for this count function, count I 769. So it is only giving me 767. So this is what happens. This is the mistake can happen when we are using count. So what we do, we prefer count A over count. So if I use count A, then it will give you the column also. Whatever, if you have value, it will go and count everything. That is why it is counting outcome. So this is another thing. So if you use count A, it will give you everything, including your column name. So whatever your column name, just remove it. Your first will be gone. So you will start from 2 till 765. Is it clear now? Is it clear? Okay, perfect. So let's go and try to see some missing bits of skewness. Okay, what are those? So here we are at yes. Now the question is how to interpret it. First thing is graph is must. We must have to create graph to be sure if it is skewed or not. So when we calculate it, so just for example, when we are calculating it, if your value is 0, what do we mean? It means it is symmetric, perfectly symmetric, but in the real life we are never going to. Okay, it is never going to be 0, but it will be close to 0. If it is skewness is greater than 0, what does it mean? Is it right skewed? Perfect. Right. It is it is skewed towards right. Okay, this is what it is. If it is skewness is 0,
Left.
left. But when we are interpreting it, we cannot just stick on no, it should be perfectly 0. That is never going to happen. Okay, it is never going to happen that your data will be perfectly 0. So there is a range called minus 0.5 till 0.5. Okay, so if your data falls this range, then we say yes, it is symmetric. Okay, then we say it is symmetric. If it is beyond that, then we say it is. If it is greater than 0.5 or if it is less than minus 0.5, then we say it is. So this is the range. If your skewness value is here, then we say okay, this is symmetric. Okay, so this is the range. In generally we prefer, but with this range, we must have to create a histogram to see if it is symmetric or not. Is this point clear? Then we will create a histogram and also see how to get skewness value. Okay, so now let's go and try to calculate skewness value for glucose. Okay, so for that, a very simple function is called SKEW. Then we just have to give the range B2, 8, B769, and if I run this, it tells me 0.17. So is it skewed or not? Based on this graph, based on the value.
Skew.
Is it more than this?
It's skew.
So what are you going to judge from this?
Symmetric skew.
Symmetric.
Based on this, we are going to judge it is symmetric. So this is the formula, skew, and then you just have to give the range. But now let's create a graph on this. If I go and create a graph of histograms, so again, glucose, go into insert, chart. Okay, so automatically it is creating some graph, but it is creating a line chart, but we are not going to see the line chart. We have to create histogram. We have to scroll down. And if we go here, so combo chart.
Sir, in line chart, you
Yes,
do like this.
this is histogram. Okay, now if I create, technically, if you use Python and all programming language, you will not see any space, but when you because spreadsheet is giving a space, but that is not the correct approach. When we create histogram, we shouldn't see any. Now, if you see this graph, do you feel it is symmetric?
No, sir.
Why?
No, sir.
I feel it is symmetric. I'm not saying there is no issue with the symmetry. Symmetry looks good to me, but there is still some issue in this data. This is glucose level, and this is your frequency. So can you see any discrepancy in this? I specifically choose this data because this data has so many issues. And I don't want to, teach with a very good data set. I want to teach with a bad data set so you can learn more.
There is a gap with 0 to 50, 45 or 50 around values. So that
Yes.
44.
that, that value is an absolute outlier.
Yes, that is the perfect catch. So what happens in this data set? So earlier, what was happening is when people were, creating data sets, so many a times they were using missing values as extreme values, which is not possible. So zero is not a possible value. Okay, when we have this value, what is happening? We have so many zeros. So let me remove this graph. So you have seen how to create it. But if I go ahead and just try to filter it, so I can click on this and then I can go and filter. Now if I go and just sort it, now you see I have some zero value. Is it or not? So is it a possible value?
No.
It is not possible. Same goes here. If I go for blood pressure, sort A to Z, so many zeros. Same goes for skin thickness, so many zeros. So technically, what happens is when the person who created this, he entered missing value as zero. So whenever we create this graph, so that is why I used specifically this data set. So you can see how data can be, horribly, wrong, and how a chart can help us to explain our data set in a far better way. Okay, so as soon as we create this graph, it clearly tells me, yes, there are some data points which is practically not possible. When we are going to do something next, what we have to do first, we have to deal with these missing values and then we have to do the process. Okay, so this, can you see how, because if you just use mathematics, you will get the result. But the real truth is coming from visualization. Okay, the issues in the data set we are seeing from the visualization. So is it clear what is histogram? What is skewness? How to interpret a histogram? How can we use a histogram to see if there is a discrepancy in the data? Is this clear to everyone before moving to another chart?
Sir, is the chart is normally distributed?
So if you see this data point based on this, yes, it perfectly looks normally distributed. Can you see like this is also like, ditching us. Technically, if I say, if I just go for the chart also, chart is also telling me if I don't explore it properly, it is telling me, yes, data is normally distributed, no issue, we can go ahead. But it's still not jump here. We have to explore it. It doesn't make sense. There is something wrong. So we must have to check. Sometimes extreme values are not possible. We have to check what is going wrong. Okay. So we have to go back. We have to check it. We have to do the cleaning, and then we have to create these graphs again to see how does it look now. If you see this, it looks normally distributed. Even if you have, because we have very less data points. So that is why it is showing something like this. If we had more data points, then there might be another issue. For example, in this one, if I go insert chart and go to histogram, now if you see, we have so many data points. In blood pressure, zero blood pressure, not possible. First person is dead if the blood pressure is good. Again, if you look perfectly, it's normally distributed, but again, we have some. Technically, I will say symmetrically distributed, not normally distributed. Okay, so I will show you in a minute why is it not normally distributed in a minute, but this is symmetric distribution. Okay, but here we have something which we have to fix. Is this clear now?
Sir, normally distributed means the data should be equal from the left and right.
That is symmetric, in general symmetric. So now let's discuss a little bit about normal distribution. We don't have to go into deep. So when we say normal distribution, if we see this graph, and we have already talked about something called standard deviation. Okay, so this is your mean value, just for example, and this is just say one standard deviation away. This is your two standard deviation, and this is your three standard deviation. Okay, same goes here. This is minus one standard deviation, minus two standard deviation, and minus three standard. So this is, we have seen what is when you calculate standard deviation, that is called one standard deviation. Okay. After that, we can have. So if your data follows normal distribution, if my data follows normal distribution by default, okay, this is called empirical rule. So if my data is following normal distribution, what empirical rule says is, we have to understand this. What empirical rule says is your 68% data will fall between plus minus one standard. Okay, your around, remember, it is not exactly 68, it is around 68. Around 95% data will fall between plus minus two standard deviation, and your 99.7% data will fall between plus minus three standard deviation. This is what normal distribution is. So this is called empirical rule. So if it is normally distributed, it will, this is what it is going to follow. So what does it mean is, if I just show you this graph, okay, and I'm saying this is one standard deviation, okay. So this is plus one, this is minus one. This is your mean value. So my 68% data is here. So do you agree with this graph? My
Yes, sir.
68, okay, 68% data will fall here. Now come to two standard deviation. So this is my around two standard deviation. Okay, this is like I'm giving hypothetical only. Can I say around 95% data falls between this?
Yes, sir.
Okay, and then if I go for the third one, it is this one, so it is like 99%, 99.7%. Can I say this 99.7% data falls between these three?
Yes, sir.
So this is what normal distribution is. So when I was showing you symmetric distribution, normal distribution is always symmetric, but symmetric distribution is not always normal. Okay, just for example, if I create a graph and it shows like this, so what do you feel now? Is it symmetric or not?
Yes.
Symmetric. Yes, sir.
But it is not normal distribution.
Yes, sir.
Okay, So normal distribution is always symmetric, but symmetric distribution is not always normal.
Okay,
Okay,
sir.
this is very important. So this is what normal distribution is. This is called empirical rule, and normal distribution will always follow this. Okay, if your data is following normal distribution, it is always going to follow this empirical. So is it clear how your normal distribution differs from symmetric distribution?
Yes, sir.
Okay, so now we are going to discuss another very important point that is called kurtosis. Okay, because that is also based on this histogram. So that is why I'm going to discuss.
Sir, can you explain the normal distribution with the previous plots, like where we had the gap?
I did not get your point.
No, like in the Excel sheet, you have shown the plot also, like where we had a gap, like you said that it's a normal distributed plot.
Yes.
How did you
So
like come to the conclusion? It is like 68% is the 68% is also not.
I did not come with a conclusion. That is rule. Okay. Just try to understand. That's what I'm saying. This is empirical rule. Basically means if your data is following normal distribution, this is what going to happen. Are you
Because
getting my point?
half part of the data was is still missing, right?
Half point of the data is missing. I am not getting your question.
I mean the data between four and four count and 48.
This is what you are saying.
Yeah, I mean the gap between that graph, that bar and the next bar. So that area is missing, right? So
It is not missing.
yeah.
This is wrong value. Okay.
Uh,
We don't expect this low level, because if someone's glucose level goes down 40 or blood pressure goes down, the person will be dead.
yeah, understood, sir, understood. But
Yeah.
you said
So it is it
it's
is
normal distributed, so that means
it is this is not normal distributed. This is what I'm going to discuss now because of this. Okay. So this is what I'm saying. In the beginning, this is what we assume. Just what I was trying to say is when we see the chart, we have to be very critical. A chart may look good, but we have to be sure with each and everything. For example, when I was showing that graph, in that graph, I said it looks like normal distribution. Okay, and based on the values, we can judge, okay, it is normally distributed, but that is not. For example, in this graph, I showed this. In this one, if I go to this one, and if I create this histogram, now it seems better. It looks more normally distributed. Okay, but in real life, theoretically, yes, it should follow this. But in real life, it is never going to say if exact 60%, but it will be approximate 60%. Are you getting my point? Approximate 68% data will fall between one standard deviation if it is following normal distribution. Try to understand the whole point here. 68% data will fall between one standard deviation if your data is following normal distribution. And if it is not, then it will not fall. Okay, is it clear now?
So, to say my data is normally distributed, should I be considering all? I mean, my data should be under first, second, and third deviations, or any one of the deviation is fine. I
No,
mean,
no, it is you are. This is what I'm saying. This is what happens in the normal distribution. Okay, when your data is generated and it is if it is normal distributed, so this is what you are going to see. You don't have to think about one, two, or three. This is what you are going to see. Okay,
okay,
you don't have to think if it is one or two or three. This is the way it will follow if it is normally distributed.
got it. Yeah.
That is why it is called empirical rule. Rule basically means when statisticians worked on the normal distribution, this is what they found. So that is why they made it a rule. If your data is not following it, but remember, in real life, it is never going to be 68%, maybe 65, it may be 72, It may be something like this. Okay, so this is what we are going to see in real life. But we have to see, that is why I'm saying we have to create graph, we have to calculate these values just to be sure what is it. Okay, so next is, yes.
How do I set the first deviation, second deviation, and third deviation values on my data set?
So can you calculate standard deviation if I give you a data set?
Yeah.
So when you calculate it, that is called for one standard deviation. Okay, so whatever the value comes, just for example, you calculated it and it came 5. Okay, so this is your one standard deviation. So 2 standard deviation is nothing. 2 multiplied by 5, 10. 3 standard deviation is 50.
Okay, yeah. Thank you.
Okay, and if it use put minus sign, then become minus. Okay. So kurtosis is the concept is very similar to, like, for to find kurtosis, we also have to use something called histogram only. Okay, but why do we use skewness? Is to see how our data is left, how my tail is towards left side or right side. But kurtosis also looks for tail, but it looks for something else. It looks for the shape of tail. Okay, this is what it looks at. It, or basically it looks at how peaked or flat it is. Okay, it is look for shape of tail and or how peaked or flat your top is. Okay, this is another thing. It looks for two things: how what is the shape of your tail, or another thing is how your how your data is looking for the peak. For example, like if I show you this graph, so this is a good graph to discuss. So if you see this graph, so I created this graph to show you guys. So if you see all three are looking like symmetric distribution, is it or not? All three are looking like symmetric distribution. But if you see the tail, if you just see the tail or peak, can you see there's a peak is very, very narrow peak. This is better peak and this is very flat peak. Is it or not?
Yes, sir.
And same goes for the tail here. If you see the tail, it is very flat tail. Is it or not? The tail is very flat here. This is like normal tail. Normal distribution is also known as bell curve. So this is called bell curve also. And this is, if you see this tail, very flat and wide. Basically, this is your fatter tail going towards this side, going towards this side. This is your flat tail. Basically, it is ending here only. And this is like a bell curve. So when you are creating a graph, apart from skewness, we also look at how my histogram is looking. If it is looking like this, we call it leptokurtic. If it is looking like mesokurtic, basically like this, basically mesokurtic or normal distribution. So this is your normal distribution. Okay, it means your 68% data will fall 1 standard deviation, 95% data will fall between 2, and 99% will fall between 3 standard deviation. And platykurtic is basically, we see it is like a flat. Okay, it is completely flat. So this is the basic thing about kurtosis. When we are looking for a data, we also have to see these things, how my data looks like. So if it is a leptokurtic, as I have already mentioned, okay, so basically leptokurtic, you are going to see a fatter tail and very high peak. In your data set, you will see very high. Okay, what does it mean? It means is, if I say your data shows you high kurtosis value when you calculating it, so what it tells me is, basically it tells me if it is a leptokurtic, it means your, in normal distribution, we say in one standard deviation, we have 68% of the observation. Is it or not? This is what we say in normal distribution.
Yes.
But when it comes to leptokurtic, we are not going to see this. Maybe 30% of the data fall between one standard deviation. Only 30%. And platykurtic, it may be 90% between one standard deviation. And when it is normal distribution, we will see around 68%. So that is the basic difference where your data is falling. So that is why it has very flat tail, it has very fat tail. Basically, your 30% data falls here, and after 30% between one standard deviation, and then rest of the data is towards tail side. Most of the data is towards tail side here. Most of the data is falling here. So that is the basic difference between leptokurtic, mesokurtic, and platykurtic. How your data is falling, how your peak looks like, how your tails look like. We also have to see these things. So not only skewness, we also have to see if my data is mesokurtic or not, to be sure that if it is normally distributed or not. Is it clear?
Yes, sir.
Okay. What it does, it helps us to figure out how outlier can affect our data. If your data has outlier, it will mostly show you, it is not going to show you mesokurtic distribution. It may show you leptokurtic. Okay. Okay, this is what it's doing. It is also useful in finance sector when you are using quality control. That is very, very important. Why? Because let's say if a finance company is looking, a bank who wants to give credit card to someone. Okay, the bank has decided to give credit card to someone. So they want to look at if the person is coming in this distribution or in this distribution.
The green
If
one.
the person is coming in this one, then the person is, it can, or and that too towards left side. They will not give you credit card. If you are in this distribution and that too like towards right side only, they will give you the credit card. So they will create these graphs to see where are you falling in the data, and based on that they will take. So this is what kurtosis is. Okay, so you see, like even for normal distribution, how many things we have to look at. Skewness should not be there. Then we have to look for the tail, peak. So let me show you the data we have. I can show you like how things will be changed. Let's go to this data set. And if you see this data set, I am not seeing. The only issue is here. The only issue is here. Rest everything looks like a symmetric distribution only when we are talking about glucose. But let's go to the blood pressure one. If I go to the blood pressure one and create chart, now you see, can you see the peak in between
Yes, sir.
this peak?
Yes,
So
sir.
what is happening? It based on this peak, maybe my 30% in one standard deviation is falling here and my 30% data is here. But I am having some fatter tail. I am having some fatter tail. So this tells me this is leptocut. But we still have some issues. And then what happens? We can also change the bin and all, and then we can also look. But we already know that there is some issue. First, we have to fix it. Okay. Is it clear how kurtosis can affect your data? How what do we say? This one. Skewness can affect your data.
Yes, sir.
Okay. So let's see how to calculate this. We can simply call AU and then kurtosis will come. And then we just have to give the value like B2 to B769. And it will calculate. If you see this is 0.6. So technically, if it is 0, we say mesokurtic normal. If it is greater than 0, it means it is having heavy tails. It is leptokurtic. If it is less than 0, then we say platykurtic. Basically, it is lighter tails and flat head. Okay, this is what we say in general. If I just go and try to show you this one, kurtosis, and then C. Now if you see 5.18. This is 0.64, which is close to 0, which is like mesokurtic. It is telling me this is, even graph is telling me it is close to normal distribution. And here, even graph is telling me it is leptokurtic. So this way, calculate this, calculate these values, and create graph, just to be sure what you are seeing. Okay. You can see from the graph, from the value, we can interpret how my data looks like. Again, I'm saying, like, you guys are just starting, so there might be some confusion in the beginning, but the more you will deal with the data, the better you will be. Okay, so I have given you diabetes data sets. So there are hundreds of data set available online also. You can download it and you can play with this and then try to see how does it look.
Sir, can you explain the range once again?
Range, this
Range
one.
for leptokurtic and mesokurtic.
So
Whether that
range is, if it is greater than 0, we say leptokurtic. If it is less than 0, we say platykurtic. Okay, so let me write it here. In generally, this is what we say, but greater than 0 is lepto leptokurtic. If it is greater than 0. Okay, and if it is less than 0, we say platykurtic. But in real life, you are never going to see, like, because you will never see exact 0. So you have to see from the graph and all. Okay, you have to see from the graph and all how does it look. So even if it is mesokurtic, it is going to have some range, like minus 0.05, 0.5 till plus 0.5. Then you will say it is mesokurtic. And if it is beyond that, then you will say decide which, if it is platykurtic or if it is mesokurtic. Okay. Is it clear? What is kurtosis?
yes, sir.
So now let's go ahead and try to finish some other graphs also, which we have to discuss. So another graph which is called box and whisker plot, okay, which is very similar to histogram only. Box and whisker plot, and you will see this graph makes more sense when you will be doing Python and all. So here is an example of this graph. So this graph, basically, this is called box and whisker plot, and we have already discussed about this. Okay. So this box is nothing. This is your interquartile. This is basically your quartile data, which we have discussed. This is your minimum value. This is your quartile 1. This is your median value. This is your quartile 3. And this is your maximum value, which is, in this case, it is, box plot is very handy to find outliers also in your data set. If you want to see outliers in your data set, you can simply create box plot, and it will also show you if you have outliers present in your data set. Number one. Number two is, like, and number two is, first I have to mention one thing. This is also for continuous data. Okay. So if we are just dealing with one variable, it is used for a continuous data. This is one thing. Another very important thing is, if I ask you this question, what is this? So this is called box, and this is called whisker. These 2 points are called whisker. So that is why it is called box and whisker plot. It is used for continuous data if we are just dealing with one variable. Interestingly, there's another important thing is, if I ask you, what is this? Can you tell me what is this?
Inner quartile.
Perfect. This is called this is your IQR, interquartile range, Q3 minus Q1. Okay. So this is what box plot is. Box plot also tells us the distribution of our data. Not only outliers, it also tells us how my data is distributed. If I just create a graph like this, it will tell me how is it distributed. For example, if I create different box plots, so let me create 2, 2, 3, then it will be helpful. So if I show you a box plot, horizontal way, so this is the, you have a data set, you created a box plot. Okay, you have another data point, you created a box plot. You have another data point, you created a box plot. Just seeing the box plot, I know this seems like a normally distributed. Okay, but we also have to create histogram just to be sure if it is mesokurtic or not. Just seeing this box plot, I can say this is right histogram. Just seeing this box plot, I can say if it is left histogram. So box plot will also help you to figure out the skewness of your data. Okay. So this way we can use box plot to see how my data is distributed, if it is skewed or not. Is this clear? What is box plot?
Sir,
Which
box which you drew here before, right? Just now,
yes.
you drew the boxes, right? So what are the horizontal lines you mean?
So horizontal, this x-axis is your data, whatever the continuous data you are using, and these are
Okay.
your values, all values from minimum to maximum. Okay, and
No,
this
the
is your.
horizontal line which you showed, like to see the normal distribution and everything. Left
So this is,
distribution.
if this is, see, this is vertical box plot. So I showed you horizontal. We can create horizontal box plot also.
Okay.
Okay, if we want, we can create box plot like this. I can show you here also, but the picture is like not that good. So that's why I created this horizontal. So this is
Okay.
also a box plot. So rather than using x-axis, I am using y-axis. This is the basic thing. Okay,
So through new diagram, we can only find this whatever details we're going to find in historical box now. So what is the need for this diagram?
we can also see outliers. Histogram will help you to figure outliers, but box plot will definitely give you outliers. There are other things also, but what happens is, just for example, if you have male and female, and there, so for example, diabetes, non-diabetes, and you want to compare their glucose level, you created it box plot, and you created a box plot of glucose level apart from calculating mean. Now, can we not say using this that this box plot is like for non-diabetic we have a low median level, a low median glucose level, and for diabetic we have high median glucose level. Can we say this now? So that is other purpose which you will see you which you are going to see more during when you will see use Power BI or Python. This will be covered in much more detail over. Okay, but
Okay,
there
sir.
are many things. These are the some basic graphs. So you will see more advanced version over there. Because even if I just show you box plot, I'm going to create a box plot, but that is not that straightforward when you use Power BI or Python. Okay, so this can be used to compare. Now it is a category. I am comparing continuously. So there are multiple types of analysis. What I am showing you is called univariate. I'm using one variate. Then we also have bivariate analysis. Then we also have multivariate analysis. So these analysis, univariate is very easy to do it in spreadsheet or Excel. You can do all of this, but then they are very tricky. Okay, so that is why you will learn these things over there in much more detail. But you should know what is box plot, what is histogram, how to interpret it. All of these you should know in advance. Is this clear?
Sir, how to interpret this?
So basically, if you see this graph, I can clearly say that this seems like normally distributed, but I also have to create histogram as well as there are some outliers present in this. Okay, there are outliers present in this. This is what we are going to interpret. Outlier is present, so I have to deal with it.
Sir, can you explain what the graph says about miles per gallon and
So
x-axis?
basically, it tells me there is outlier present in my data set. So maximum value, there are some outliers which I have to explore. And if I go ahead, so my median value is close to 19. Okay, and it looks like my data seems to be normally distributed. It looks like. For that, I also have to create histogram to compare. This is what it generally it tells me. Okay.
So that's a whisker circle. A whisker, if it is symmetrical, then you can say it's normal distributed.
Yes, based on whisker only. Because your 50 box only represent your 50% data. 50% data is falling on whisker. So if it is like this, then if whiskers are close, equal, nearly equal, we say yes, data is symmetric. If one whisker is very long in comparison to another, then we say data is skewed. Okay, is this clear now?
Sir, how can we find out the outliers in this whisker box plot?
So if when I created this, you can see this data point. It will automatically create it. Okay, if it is one, it will create one dot. If there are multiple, it will create multiple dots. It will automatically find these, and this is only in Python and Power BI. In the spreadsheet, it is difficult to find outliers. I will create a box plot, but you will not see any outliers over there.
Sir,
Okay.
can you explain this box with data, sir?
Okay. So let's go to our data set. So when we are creating this box plot, so there are multiple things. So let's go ahead and create this box plot for blood pressure. Okay. So we need some information before creating it. So let's go down because I need multiple values. So let's say I need first label. Okay, what are this? First thing is minimum value. How to get it? Minimum. Then I have to give the range C 2 to C769. Okay, this is my minimum value. Then we have to go for quartile one. So quartile one is QUARTILE quartile, and then C2 to yes, it will ask for 5 values which we have to give, otherwise we will not be able to create it. Okay, so quartile. Okay, I
Sir,
did
you
not
did
give.
not mention first quartile. Yeah.
Yes. Then I have to give median value, which is quartile 2. Let's say this one only. It is taking P, so I will change this to C2, C769, and then quartile 2. And then let's go for quartile 3. So is equal to quartile 3, 769, and then comma. So this is where we got Q3, and then we have to get this max value. Now max is equal to max, and then P2, P7. Okay, so this is what we have. Now what I'm going to do is, just for example, what we will do, label is blood pressure. What I'm going to, I will highlight this and go to the chart. Okay, now you see it automatically created box plot for me. So if you see, we have outliers here, but it is not showing any. That is the one disadvantage of spreadsheet. If you go for more advanced level, definitely. And then you see for box plot, the chart is called candlestick chart. So we have to get these 5 values highlighted, then only it will create a box. And if I see this box plot, if I just see this box plot, it clearly tells me it is leftist. But if you remember when we saw the histogram, it was not giving the same picture. But here it is giving me, it is telling me it is left. Is it or not?
Sir, how can we say whether it is left or right?
Just seeing this bar graph, is it not like this? Is this way we have data is more stressed, and this
Yes,
way
yes.
we, because remember, this represents 50%. This also represents 50%.
Okay, sir.
Histogram. Advantage of histogram over here is histogram will, if there is no value, histogram will not show anything. But box plot will still show. If there is no value also, it will show something. That is the one advantage. So you have to create multiple plots, histogram, box plot, calculate skewness, then try to explore it more, and then only you will be able to find if it is right or wrong. Okay, is this clear?
Yes, sir.
So now we'll go for the last chart, which is called line chart. Sorry, there are two more. Last, line chart and scatter plot. So line chart. So line chart is basically when we try to see trend like Sensex. Okay, so how things are changing. This is what line chart says. So basically means you are going to have two variable. X is you're going to be your time, and Y is going to be your continuous. Okay, so this is what happens in line chart. Line chart always show trend. This is what we have to remember. How things are changing based on time. It can go up, it can go down. But when we talk about scatter plot, it shows relationship between two continuous data. This is the difference between these. Many times I have seen people use line chart for relationship and scatter plot for trend. So we have to be cautious with this. If we want to create, if we are interested to see the trend, how things are changing based on time, we create line chart. If we want to see the relationship between two continuous data, we create scatter plot. That is the basic difference between these two. Is this point clear? So this is I am telling because this is what I have seen people get confused. So they create the wrong charts in these two. Okay, so here what we are trying to see, we are trying to see the relationship between miles per gallon and car weight. So what it tells me, if I see this, it tells me if miles per gallon goes up, car weight goes down. This is what it is saying. If my weight goes up, miles per gallon goes down. So this is what it is telling me. I'm trying to see a relationship between them. But if it comes to line chart, it tells me, shows me the trend, how things are changing, and I'm sure like everyone of you must be aware of Sensex or Nifty 50. So it is basically how this is the GDP per capita of India from 1952 to 2007. So as the time is going up, our GDP is also increasing, going up. So this is what line charts. Okay, so this is the basic difference between line chart and scatter plot. So let's create a line chart because I need a new data. We don't have. So in this one, not in this one. Let's go to this one. So I already have a data set, so let me use that only. If you see in this data set, I have three things: month, January, February, March, and then we have temperature. So do we have time here? Do we have time?
Yes, sir.
Same, now we have temperature value. Temperature 1 in January. Just for example, this is for three different countries like India, US, Denmark. Just we can imagine like that. So now if I want to create a line chart, I will highlight my x-axis, which is time, and y-axis, which is value. If I go to insert chart, it is showing me bar graph, but because we are interested in trends, so I will go to column chart, and then I will go to the line chart. If you see based on this, I can see how things are changing. It might have been better graph, but this is what it is. If I just want one country, I can select only one column. If I want to compare multiple countries, I can use multiple columns. Okay, so this is what line chart. Basically, we are interested to see the trend, how temperature is changing from month to month. From January, the temperature was around -5. Now in February, it became 0. In March, it has gone up. So this is what we are trying. So is it clear what line chart tells us? Everyone. So line chart basically tells you the trend, how things are changing based on time. For example, how temperature is changing. For example, like in India, temperature will be less in January and December. This is what it is going to tell. Share market. Just let me open something for share market. Let's go for relax. So if you see, this is line chart. So in one day, how the things changed. Share went up, share went down, then it went slowly, it went up. If I go for 5 days, so it is again showing me in 5 days how share is changing based on time. If I go for 5 years, it is again showing me the same thing, how things are changing based on time. On 3rd July, this is the price. On 18th September, this is the price. 8th October, this is the price. So this is what we try to see using line chart. We are trying to see how things are changing based on time. Is this clear now? Okay. Scatter plot is basically, let me remove this. Basically, to see the relationship between two continuous variable. I want to see how glucose and BMI is related. So I will go and create insert chart. I will go for down scatter plot, and I am getting this value. Basically, it is taking minimum, maximum. So let me delete those first. So this is your glucose, and this is BMI. If I go chart, now this is the chart. Okay, so this is your scatter plot because we have some zero value, so that is why you are seeing some values at this corner and this corner. You just select it, it will automatically select a scatter chart. Basically, we are trying to see if there is a relationship between BMI and glucose. So this is what we are trying to figure out. If BMI goes up, glucose goes up or not. If glucose goes up, BMI goes up or not. So this is what we are trying to see. So when we create these charts, so you are going to see in general three types of charts. One, your data may look some. This is what I'm explaining now. You may see your chart may look something like this. Your data point may look something like this. This is your X and this is your Y. So if your data points look like this, it means if X goes up, Y goes up. This is what it means. If X goes up, Y goes up. Basically means there is a direct relationship between these two. Is it or not? This
Yes.
is what it means. If you are seeing a chart like this, your data point seems like this. So it means if X goes up, Y goes down. When X goes up, Y goes down. It means there is indirect, basically inverse relationship between these two variables. If one variable goes up, another variable goes down, which I just showed you about mile per gallon and weight. So that is called inverse relationship. And then you will see a chart like this where there is no change. So it doesn't matter if one goes up or one goes down. So this is called no relationship. There is no relationship between BMI and glucose. This is what this chart is. So yes, we use this chart to calculate correlation. We calculate correlation value and we use scatter plot to see this. Okay, so when we use correlation, we also see the strength of the association. Okay, so this is what scatter chart is. Is this clear? What is a scatter chart? How to interpret it? Okay, and now let me show you the correlation part. That is the last part, and then we will see more about this scatter. So if I have to see the correlation, what I am going to do is I will call this function called CORR. Okay, in this I have to give two values. I have to give two values, which is B2 to B769. And then I will explain what does it mean. C2 to C769. Not C. Basically, we use BMI, so it is F2 to F769. Okay, unknown. Okay, this is correlation. So again, B2 to B769, comma, C2, 6. If I run this, it gives me 0.15 value. Okay. So this is the formula. Let me share it with you also. I am sharing this with you in chat. I will also share this formula in my sheet, which I have created. So this is correlation. This is the formula to calculate it. So correlation is again like scatter plot. We are trying to see the relationship between two variables, two continuous variables. So this is most important thing. Two continuous variables. So this is what we are trying to do. When we calculate it, for example, we have seen the graph. For example, if you see this graph, where is it? This graph. Can you tell me, is it direct relationship? I have written it wrong, but this is inverse relationship. Is it or not?
Yes. As
Yes,
a
sir.
Yes, this is inverse relationship between these two values. If I calculate correlation analysis, so what happens is when we calculate this, it gives value between -1, sorry, -1 and 1. So value will always between this. If your value is plus, it means it is towards direct relationship. Towards direct relationship. Okay. If it is minus, it is towards inverse relationship. That is the first thing. Okay. If it is 0, then we say no linear relationship. Basically means if it is close to 0, we say no linear relationship. If it is plus minus 0.8 or more, okay, we say strong relationship. Strong relationship. Rest everything depends on your sign. If it is plus 0.8, strong positive relationship. If it is minus, we say strong negative relationship. Same goes here. If it is somewhere between 0.3 to 0.7 plus minus, so it completely depends in which direction is it going. It completely based on that. So we say it is a moderate relationship. Moderate. Okay. And if it is less than this, we say weak relationship. So if I just show you this data, so first thing we have to see if it is positive or negative. It is 0.15. Is it positive? Direct. What are we going to interpret from this? Direct relationship or indirect relationship?
Direct.
Number
Direct
one.
relation.
First thing is direct relationship. It means it is towards positive directions. Now we have to interpret. What are we going to interpret? Is it a strong? Is it moderate? Or is there no relationship? Or is it weak relationship?
Weak.
Moderate.
It is not moderate. It is 0.15.
Weak relation.
It is very weak relationship. Not a strong signal. Strong is 0.1, zero point 0.8 or above. If it is 0.8 or above, then it is strong. It can be positive, it can be negative. But if it is less than 0.2, if it is less than 0.2, then we say it is a weak relationship. It can be plus, it can be minus. So this is what correlation analysis. Many a times you want to see if house size will affect house price or not. What will you do? You will perform correlation analysis. Okay, you will perform correlation analysis to see if a house price is affecting it or not. And correlation analysis is always complemented with scatter plot. Whenever you are doing correlation analysis, always use scatter plot. That is what you see. If you see here, we are seeing when I show you this Anscombe chart. So Anscombe chart is basically nothing. We are using correlation. We are just doing scatter plot. Scatter plot is all four are scatter plot only, and this R is, if you see the R value, this is your correlation value. And by default, we say it is a Pearson correlation value. Okay. But interesting thing about, I will just make a notes also on that. We only do Pearson correlation or like Pearson correlation analysis. We only do Pearson correlation if my data is normally distributed. Both data points should be normally distributed. So one thing. Okay, that is the first thing. If it is normal, then only we do the correlation analysis. Second is no outlier. We should not be having any outlier. Otherwise, my correlation value will change drastically. It can affect my correlation value. So we also have to check if outliers are present in my data set or not, which we have seen seen this in ASCOM chart. So if you see these chart, if you see this, why are we seeing very high value? Because of this outlier. Because of this outlier, we are seeing a very high value. So this is what we also do. Scatter plot to check all of these things. And correlation, once this is fixed, then we perform correlation analysis. Okay. So is it clear what is correlation analysis? What is a scatter plot? The one thing I will suggest you to remember, the difference between line chart and scatter plot. Line chart is to see the trend, scatter plot is to see the relationship between two continuous values. And scatter plot is always complemented with correlation analysis or vice versa. Correlation is always complemented with scatter chart. We have to create a scatter chart, otherwise we will do the mistake we are seeing. Create a scatter chart, check if you have outliers or not. If you have, deal with that outlier and then go for the Pearson correlation analysis.
So,
Is
sir,
yes.
regarding the house prices, right? We you said that scatter plot we will be using. So house price may not be affected by single value, right? I mean, like only the location or only the size.
It technically it is not. So that is why you are going for machine learning, and that is why we do regression analysis.
Okay.
Okay. So after correlation, regression comes, which you will see in regression.
Okay.
Okay. This is just to show you. But how are you going to find which variable is important? Because when you will collect data, there may be 200 variables. But how are you going to find which one is important, which one is not? For
How?
example, if it shows good correlation, it is important. If it is not, then it is not.
Yeah. Yes, sir. Thank you.
Okay, because
Understood.
in machine learning model, we have to put in important variables only. If variable is important, we are good to go. If variable is not important, we have to leave it.
So basically, based on the correlation which each feature, the top correlated features will be taken up for the input.
Yes, yes.
Thank you.
So those making sense. But remember, but it is only for continuous data,
Yeah.
continuous to continue.
Understood. Thank you.
Okay, perfect. Any question, any doubt?
Sir, the line is not showing in the correlation, no, sir. This line.
So that is
Red.
called regression line. Okay, so you will see when
Okay,
I'm
sir.
creating this plot, I'm not showing it right now, but when you go for the regression plot, when you will go for the Power BI now, you will see all of this. Technically, if you see, if I go for the custom chart, there is an option to add. So, so you can definitely go and play with this. Okay. So there are so many charts, so you can definitely go and add those lines. So this is scatter plot. If you go and customize it. So let me go see grid lines and text down, major grid lines, major grids. So here we have options. We can go and check which option is like to add line and we can add it. Okay, so we have this customization option here and we can use this to lights. Let's see. Now this is trend line. Now you see line is added. You can change the color. Now if you see the color is, so this is the line. Can you see this now?
Yes, yes.
Okay, so we can do that. Any question, any doubt? So guys, we have discussed so many things, so many things. It's not one or two things, but so I'm not expecting that you are going to remember everything in one shot, but the more you will revise, the more you are going to remember. Always remember one thing, stats is the base of data analysis. Okay. Any question, any doubt? Over to you, Ravi.
Sure, Sandeep. So guys, first thing I just want to confirm with everyone whether are you able to clear with all the concepts that has been taught yesterday and today? Is everything is clear to everyone? I want response from everyone. Perfectly fine, perfectly fine. And thanks a lot for all your responses. So guys, firstly, I request everyone to practice again on whatever the things you have learned yesterday and today. And then later on, for sure, you will be having a doubts for the things that you have been practiced, and those doubts can be clarified in the doubt clarification session which we will be conducting on the weekdays. So in order to know when your doubt clarification is scheduled, I request you to check the announcements and the calendar on the LMS portal. Mostly it will be on Tuesday or Wednesday, but please you check it on a daily basis. Make a habit to check the portal on a daily basis, so that would be really helpful for everyone to not to miss any of the schedules. And today's files are already shared in the chat. I request everyone to download them. Yep. And just allow me a moment. I'll even show you what all the task and all you need to do in the weekdays. I mean, what you will be doing on the weekdays, the things that you need to practice and all. So allow me a moment to share my screen and clarify all of your doubts. Yes, Vivek, for sure you will be coming up with the questions once you do the revision. So those doubts can be clarified in the doubt clarification session. Guys, I hope my screen is visible to everyone clearly. Can you please confirm me over a chat? Yep. Thanks for the confirmation, Sejal. So I won't take much time, just 2 to 3 minutes. I request everyone to focus on the things I'm just clarifying right now. First thing is, today I can see, I mean, few of the students were facing a difficulty to join the session in the morning. So first main thing you need to do is, once when you log in onto the LMS portal, there is an option called dashboard. So on this dashboard only, on the right hand side under the today's classes, you will be able to see the session schedule for you, and this particular option will be visible to you to join the session. So I hope this thing is clear to everyone first of all. Right? Yep. Thank you for the confirmation, guys. Now the main thing you need to do is, like, whenever you need to access anything from your portal, you need to click on my courses. Under my courses you will be able to see the batch called DS56A. Firstly, I'll show you how you will be accessing the recordings. So once you come on to the batch DS56A, make sure you click on class records option. After clicking on class records, you will be able to see the session recordings that has been happened till now. And one thing I just want to clarify, as in coming 2 to 3 days, this month will gonna end. So once the month is end, you may not be able to see the class dates, class recordings. So if you are unable to find at that time, make sure you are just changing the option in the date range. So if you just click on this particular icon, you will be finding different options. So depending upon your convenience, you need to change the date range, like week wise, month wise, or year wise, to access all the recordings that has been happened till now. Okay, guys. Doubt clarification session will be in the evening from 6 p.m. The further updates and all will be updated on the LMS also, so I request you to check that. So guys, I hope accessing the recording is clear till now. Can I just get a confirmation for that? Yes, no, maybe. Perfectly fine. Thank you, guys. Thanks for your responses. So in this way, you will be accessing the recordings. Then comes the things that you need to work on. Firstly, once you click under the contents, you will be able to find the agenda is nothing but the topics that will be covered during the session. So from the coming week as well, whenever, I mean, before joining the session, I request everyone to take a look over the agenda, the topics that you will be going to learn, and it would be better if you just have an idea before itself regarding the agenda. Then comes the module notes. So this particular module notes is nothing but the notes related to the topics that has been covered in these 2 days. So for your reference, if you just want to go through again, you can clarify your doubts referring to the module notes as well. Then comes the task. Classwork task, homework task, and assignments are the three different things that you need to work on. Firstly, I request you to take over a look at classwork tasks. There are certain questions assigned to you, so you just need to take up the questions. Particular data set is also provided where you can download this data set and work on the task questions that has been provided over here. So you can just take up the question, solve it in a particular file, and you can just keep that file for the reference from on your end itself. So the same follows up with the task, classwork task day 2. Then comes homework task day 1, the same thing, homework task day 2. Then comes homework task day 1, the same thing, 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 homework task Then comes assignments. Assignments, in order to access the assignments, you need to click on attempt now. Then you will be able to see few questions. You need to work on all these questions. After working on all these questions, that particular file which you have been worked on need to be submitted over here. So before submitting, I request everyone to zip the particular file and then click on choose file to submit. After choosing the file, you need to just click on submit to successfully submit your assignment. So I hope clear how to submit your assignment, right? Or having any doubts? Sure, I'll do that. So in order to, first of all, classwork task, homework task doesn't have any option to submit, but the thing that have an option to submit is assignment. So in order to attempt and submit the assignment, first make sure that you are on the assignment option. And in order to work on assignment question also, you can see different data set is given. So firstly, you need to download this data set. Then you need to come to the assignment week 1. In order to access the questions, you need to click on attempt now. Different questions are available on the left hand side. You can see 10 questions are available. These questions need to be worked on using the data set in a particular file. You need to save that particular file and zip that file. Then you just need to click on choose file. Once you choose file, you will be able to see the file which you have been zipped. You need to select that file and click on submit to submit the assignment. So Nitin, I hope it's clear now, right? Thank you for your confirmation. So the thing which is mandatory to submit on the portal is assignments, and I request everyone to complete these assignments till Friday. 5 days you will be having a time. In this 5 days you will be having a doubt clarification session as well. So after the doubt clarification session and all, you can submit the assignment, as well as there is a one more option available called practice test. So after completion of all classwork tasks, homework tasks and the assignments, I request you to take up this test, because this particular test will depends upon only this particular week's topics that you have been learned. So the main thing that you need to submit, complete and submit is practice test and the assignment. So in order to attempt the practice test, you need to click on attempt now, give the declaration and you can proceed further. Firstly, you will be even able to have the solutions file for the particular task that you have done. But I request, without depending upon the solution file, first give a complete try from your side. Give your 100% to solve these particular questions. Even after trying, if you are facing a difficulty, then you can refer to the solution files for available over here. So till now, any questions, guys? Sejal, not all the questions have to be solved in different files. You need to solve all the questions in a single file. Rupesh, in order to open the assignment, you need to unzip the file first. First unzip the file, then you will be able to access the data set. Shiva Ramakrishna, actually these assignments and practice tests related, we will be sharing a report with you as well. As a reason, we are asking you to complete it by Friday. Coming to the evaluation part, it is an internal evaluation. No need to worry. Just focus main on the submission part. Submission is the main thing. Evaluation will be done internally. In order to unzip the file, Anil, you just need to give a right click on that same file. You will find the unzip option. Classwork task, homework task doesn't have any kind of submission. You just need to work on those tasks and keep the file safe with you. Only assignments and practice tests have a submission. I hope, Janvi, it's clear to you. Yep. So these are the main things that you need to do every week once you are done with the 2 days of session. And the last one thing I just want to clarify, as few of you have been asked, few files have been shared by Sandeep today, right? Yesterday also few files has been shared. So whenever a particular file is shared during the session by the instructor, those files will be made available on the LMS in the same way. As you can see, in class resources day one. So these files are related to yesterday's session. In the same way, files related to today's session will also be made available over here. So whenever you want to access the file shared by instructor, you can do it in this way. So I hope everything is clear till now. If you guys are having any doubts, please put it over a chat. I'm happy to help you. If no doubts, just give me a confirmation so that we can end the session. I hope assignment submission, accessing the assignment, accessing the classwork task, homework task, everything is clear to everyone. Sai Krishna, doubt clarification session will not be there on the weekends. It will be there on the weekdays. Prachi, may I know what is the doubt you are facing in assignment? Actually, you want me to click on assignment week 1. Okay. Could you please clarify what is the doubt? Please refresh the portal once, Prachi. It would be better. Because see, on my page, it's nothing available like that, right? I am able to access the assignment. So please try to update your, refresh your LMS. Uday, the doubt clarification session will be mostly in the evening, starting from 6 p.m. As a reason, I said you check the LMS calendar to know the further updates and as well as the announcements. Solution file is available from 10 a.m. If you can see, assignment questions are not available in that way. Assignment questions are able to access. I hope you are on the solution file. Assignment solution file will be available from the time mentioned. I hope it's clear now, Prachi. 6 p.m. to 8 p.m. The doubt clarification would be from 6 p.m. to 8 p.m. or 7 p.m. to 8 p.m. So the last one more thing I just want to convey everyone. As you all know, you're sharing the feedback from yesterday. Once the session is done, please do share your feedback and let us know how did you felt about the session. Where 9 and 10 are consider that you are satisfied with each and everything. And I even request you to mention comments about the session that you felt. That would be really helpful. If there are anything that needs to be improved from our side, for sure we'll do that. Yes, Saiteja, you are correct. You need to create a new file from your side only. It would be a notepad or anything, depends on you. Then mention question, solve the that particular question. In this way, you will be doing that. Zip the file and submit it on the portal. Anil, the doubt clarification session would be on Tuesday or on Wednesday. So that's it from my side as well, guys. Any further doubts, any further questions? Can you please confirm me? Kindly confirm a last confirmation, yes, no, maybe, so that I can end the session. Yeah. Apart from this, if you are having any further kinds of doubts, I request you to drop an email to success@ordinschool.com. Thank you, guys. Thanks a lot for your patience and understanding. Have a great day and a happy weekend.